Hello, my dear lions. Welcome to the first lecture of our roar series, which is for JEE 25 and JEE 2026. So, all the students, a very warm vanakkam, endariki namaskaram, and yellaruge welcome. Nice to see all of you. Hello, Naisari, Avanshri, Abhinav. Hello, Dharani. Hello, Divakar. Hello, Abhinav. Hello. Good evening, my dear warriors. Now, this roar series, like I introduced yesterday, is a full-fledged YouTube series, which is one of its kind. First of all, it's in pure English. Number two, these lectures are going to be detailed with three levels of questions. Level one, which is going to be basic, then level two, which is going to be, mains level here and there, and then level three, which is going to push you beyond mains till advanced. So, my dear warriors, apart from the different questions practice, we will start with the theory and then we will see the question, theory, and then the questions, so that you have adequate command over the subject. Not just that, you will get the entire handwritten notes of whatever I'm going to do today in the Jungle Book. The link of the Jungle Book is there in the description box, which is a nice sheet arranged for all of you, where you will get all the PDFs, notes, lectures, everything systematically arranged. And over a period of time, this Jungle Book will be one source of your all the lectures at one place. Okay, so let's get ready. There are going to be PYQs, of course, and everything else will be shared in the Jungle Book as well as the Telegram channel. So in the comment section of this particular video, you might be seeing the Jungle Book, the Telegram channel link. So today we are starting off with units and dimensions, and I'm pretty sure you are all excited, just like the Tom cartoon out here. But by the time you reach rotation, I hope you do not become like this, because it all starts with great excitement. What matters is also whether you can carry it forward. Hello, Mohammed. Hello, Thali. Hello, Kanika. Hello, Leah. Hello, Hariharan. Hello, Hanuma. Abhinav already joined. Very good. Good evening. Good evening. So the point is, you start with good Josh, you start with great energy, but it should not die out. So make yourself a promise that you probably have next 6 months, 8 months, depending on which standard you are in, to crack the JEE means. Set a target, watch these lectures live, recorded. I don't know whether you might be watching it next year, even year after that also. So set a target and complete these series of lectures as soon as possible. We are going to be committed. You need to show that commitment. All right. So my name is Captain Shreyas. For those of you who do not know me, teaching kids for a very long time, more than 13 years now, and sending these kids into the colleges. And now it's your. So NEET 2024, JEE 2024 was a successful year for all of us. Lots of students did really well, and we are proud that we did so many sessions, so many lectures for them, that literally they were prepared for every exam which is on their way. Now it is your turn. Make the best use of this JEE English channel, which is one of its kind. You will love not just the channels and the teachers, but you'll also love the subject very soon, in case you have not fallen in love. Okay, so guys, I've done my research from IIT Bombay, did my graduation from NIT Nagpur. Now it's your turn now. So let's get set, go. Smash the like button in case you haven't done that yet. All right. Okay, let's roar. All the warrior pandus. All the warrior pandus whistle podwing. That's WPWP. That's the hashtag which you're going to follow throughout the series. WPWP, right? That's for your captain Shreyas Sir. And you are the new lions now who are going to roar. Cool. Let's begin with the lecture. And let's start with something called as the physical quantity. Now, this whole chapter deals with physical quantities, units, dimensions, and errors. That is the flow of event for this particular lecture. Okay, for this chapter which you are going to study here today. We'll start with quantities. We'll go to units, dimensions, significant figures, and or rounding off and all of that. And then we will go to basically errors and their combination. Now, when we say a physical quantity is something which can be measured. Like, for example, if I ask you how excited you are, you will be like, yes, sir, I'm very excited. I can't measure that excitement. I can't just say very excited is, of this level, low excitement is of this level. I mean, you cannot associate numbers with it. I cannot even associate, I have Fever. Fever, I'm feeling more feverish, less feverish. It's a very relative and subjective term. But when I say I have 100-degree Fahrenheit fever versus I have 99-degree Fahrenheit fever, then because the temperature is used now, or I'm associating it now with temperature, which can be measured in numbers, that's when it becomes a physical quantity. So temperature is a physical quantity, whereas fever is not a physical quantity. Similarly, there are many such physical quantities, like you have length, mass, time, force, velocity, speed, acceleration, momentum, field. So many quantities are there around you, right? Area, volume, density. Correct. Very good. So Kanishka, we'll start with class 12th parallelly. This week we'll just do the basics so that we have some basic understanding. Then we'll do class 11th and 12th almost parallelly. You will see that. Okay, great. Now that any quantity which can be measured is called as a physical quantity. This physical quantity can be classified into two types. So whenever you have a physical quantity, we can classify it into two categories. One is basically called as fundamental quantity versus something called as derived quantity. Derived quantity. This is one way of organizing them or classifying them. The second way is, which we are going to study in the next lecture, one is called as a scalar quantity, the other one is called as a vector quantity. Most of you have dealt with scalars till your school level. Now vectors is the thing which you need to learn till in the JEE level. We will learn about this in the other class. There is a separate chapter only called as vectors and scalars. Forget about it for now. For now, let's concentrate over here, which is fundamental versus derived. What is the meaning of the word fundamental? Fundamental, the word itself says that it is very, very basic. It is very, very basic, or it is very, very empirical. Empirical. Empirical means it is too low or very, very like natural. I mean, it is like taken for granted, like it has to be there. It is very, very, very foundational level or basic level. That is the meaning of empirical or basic. So there are some entities which are very fundamental. Example, length, time, mass. Very, very fundamental things. Any other things are dependent on these things. Any other thing is dependent on these things. So those are called derived because they are dependent. They are dependent. What are they dependent on? They are dependent on these quantities. They are dependent on these quantities. I will give you a very, very simple example which will make you understand this. When I say, when I say a fundamental quantity, when I say a fundamental quantity, very, very basic quantity, like mass, you can directly, put it in a pan and measure it. It's so basic, so fundamental, right? I can call mass as a fundamental quantity. I take a scale and directly measure something, and that means I can directly measure the length of the object. I have a watch or a clock, I look at the time, directly I can measure it. So that is basically another fundamental quantity. Now, imagine I talk about speed. If I talk about speed, for getting speed, I need the quantity called as length, by which I can measure the distance, and I divide it with time. So speed depends on length as well as time. That is why it is a derived quantity. That is why it is a derived quantity. Agree with this? Similarly, even volume of something, let's say a cube, it's basically side into side 1 into side 2 into side 3. Basically, you take length of one side into length of the other side into length of the other side. So length is multiplied 3 times. So I can think of the fundamental quantity of length coming 3 times. So length cube, right? So volume becomes a derived quantity because it depends on the length. In fact, even the quantity like density is also a derived quantity because it depends on mass and volume, but volume itself depends on volume itself depends on length. So it is length raised to 3 below and mass on the top. So all these are examples of derived or dependent quantities. What are they dependent on? The basic empirical things like mass, length, time, etc. Correct. We will come to charge also. Yes. What do you think is charge? Is it a fundamental or is it a derived? The thing is, the way the charge or currents have been defined, it so happens that current is more fundamental in our system of choice that we have, and charge is a derived quantity. So yes, you will see that it is the current which is the fundamental quantity, because you will see later on in the chapter of magnetism how current is defined by placing two wires adjacent to each other and measuring the force acting per unit length and all those things. But current is fundamental and charge is derived, because current is charged by time. Charge will be basically how much current is flowing. You multiply it with the time. So you can see two dependent quantities, fundamentals. So this becomes a derived quantity. Understood, my dear warriors? Yep. Yes, current also depends on time, but it is fundamental quantity. How, sir? So it depends on how you choose as fundamental. This is a very valid doubt, Kevin. Why should speed be derived and length and time be fundamental? I can say no, 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 no. Wait a minute. This is not fundamental and this is not derived. In some another world, Kevin's world, like Kevin asked a doubt. Length is velocity multiplied by time. I can take time and velocity as fundamental, and then I can take length as derived quantity. Perfectly okay. Nothing wrong in it, but that is in your universe. Just like you have, DC and Marvel universe, right? Same way in your world, your line of thought, in your universe, no issues. But it has to be accepted widely. So all the scientists, engineers, mathematicians sat together and they thought, okay, let's decide which is fundamental, which is derived, or else everybody will say, no, for me, this is fundamental, this is derived. So it is just a matter of historical convention that we assume length, mass, time, current as fundamental quantity. Got it? Understood, my dear warriors? Yep. Yes, there is a quantity called tensor eventually. We'll see. I mean, you will see that in engineering and all that, but in JEE physics, you don't see anything about tensors. Got it? Clear? Yep. Shri Varshan will be solving level 3 questions, which is JEE advanced level. Everybody with me? Understood the true difference between fundamental and derived? Who decided fundamental and derived quantities? All of us. Just like we decided we are going to drive on the left side of the road. One can question, why only left side? I can drive on the right side. So we need to have some kind of rules. That is the reason why we decided what is fundamental and what is derived based on a general, opinion. Okay, scientific opinion. Great. So we saw that there are two types of physical quantities. Physical quantities are the ones which you can measure. There is a number associated with it, unlike happiness, which can't be measured. And fundamental is very basic. Derived depends on the fundamental quantities. Now, in our universe, we have 7 fundamental quantities. Scientists and engineers saw all the things around us and they saw that many of these things depend on other things. And if you assume these 7 fundamental quantities, everything and anything in this universe can be derived using these 7 quantities. There is nothing as of now, at least there is nothing as of now which you cannot get using these 7 quantities. So what are those 7 quantities? I will come to it, but also keep in mind there are also 2 supplementary. What is the meaning of supplement? You all have written board exams in your 10th, or maybe some of you are droppers and written it in 12th. You get a main booklet and you are a topper, or you are writing too much lengthy answers. What do you go and ask the invigilator? A supplement, right? You ask a supplement, right? So it's an additional thing, right? So same way, scientists realize, oh, there are these 7 fundamental quantities, and you can get any other quantity using these, fundamental 7 quantities. Then they realize, oh, wait a minute, there are 2 additional ones, but they are a little bit special. They need some special treatment. So they added 2 more supplements. Supplementary, yes, additional. Wow, some of you got 497. Wow, crazy. Awesome, awesome. Here, additional. So same way, these are additional quantities, but they have some special thing. Or else somebody will ask, sir, why not then call it as 9 fundamental quantities? 7 plus 2 is 9, no, sir. Why chumma call it supplementary? There is a special thing about the supplementary quantities. We'll talk about it. But for now, let's see what are those basic 7 fundamental quantities. First one, remember this, length, the length of an object. Second one, how much matter is there, mass, how much quantity of mass, matter. Time, how much time has gone, elapsed, what is the time. Yes, electrical current, which I was just telling you, is a fundamental quantity. Temperature, temperature in thermodynamics, you'll see, you'll measure the temperature of any body. It is also a fundamental quantity. Light intensity, you will see the luminous intensity is also a fundamental quantity. How intense that light is. Okay, you will generally not see this in JEE, but it is just there only in this chapter. You will not see this luminous intensity in any other chapter otherwise. Quantity of substance, yes, you will see this not only in physics but also in chemistry. So quantity of substance, the intensity of light, temperature, electrical current, time, mass, and length. 1, 2, 3, 4, 5, 6, 7. By heart this and store it in your memory. Everyone with me? Everyone with me? Shri Vishnu, the class has already started. Yes. Okay. Clear? Very good, Kailash. Good evening, aesthetic kiddo. Everybody clear till this point? Very good. Very good. Awesome. Now, what are the 2 additional supplements? The 2 additional supplements are plane angle and solid angle. Now, plane angle is something which you learn, at school level. Solid angle is something what you will learn probably in electrostatics and, Gauss's law later on in 12th standard. But just to give you a very vague idea of what is a plane angle versus a solid angle, a lot of people have this confusion. Plane angle is basically an angle in 2 dimension. You take any 2 lines, you see what is the thing between them. The thing between them is called as the angle, which you call as the plane angle. This is a angle in basically 2 dimension. Obviously, you can think what a solid will be. It will be an angle in 3 dimension. So now when you have 2 lines in that plane, the thing between them is called as the angle. In 3 dimension, just visualize something which is encompassing or enclosing some object. It could be anything, guys. It could be just anything. It could be as simple as this particular t-shirt. Okay, just imagine you take a line and go along the boundary of this t-shirt. You go along the boundary of this t-shirt. Okay, or maybe you take this particular surface, I don't know whether you can see it, and you take a line and point it everywhere along the surface or the circumference. Okay, you go from here, you go like this, like this. So the thing which is there inside is called as the solid angle. So you can see this was that particular surface. I hope you can see that this was that particular surface. You take this line and slowly move it around this. So this particular thing over here, it is in 3 dimension. That is called as the solid angle. That is called as the solid angle. Visualize this in 3 dimension. And you will see this later on, that just like when you have an arc, the length of an arc is basically radius times the angle. You will soon see that if you have a patch, if you have a surface, then the area of that surface will be square of the radius multiplied by the solid angle, multiplied by, this is Ohm symbol, but this is I'm using the symbol for solid angle. Okay, so just like length is radius into theta, then area of this is a radius square into the solid angle. That is how the solid angle is defined. For now, you just need to know this much. It is more than enough. Just now, you just need to know this much, more than enough. That's all. Angle in 3 dimension, angle in 2 dimension. 2D means I just need two lines. And in that plane, what is the thing between them is the angle. In 3D, I will take a line and I will, go along the circumference like this. So the thing which is enclosed by this line inside, that is called as the solid angle. These are the two supplementary units. It's the two supplementary units. Perfect. So we have seen what is fundamental. We have seen what is derived. Derived, I showed you so many examples, guys. Force, velocity, etc. And the entire physics, right from chapter 2 to the last chapter, is just studying these physical quantities. And I gave you all these examples of fundamental versus derived right over here only, I guess. Where did it go? Yes, fundamental versus derived. I gave you a lot of examples right over here. I can show you some more examples over here. You can see this. For example, frequency is 1 by time. 1 by time. Time is a fundamental. Frequency becomes dependent on time, so it is a derived quantity. Force is mass into acceleration, so force is a derived quantity. Work, energy, heat, all are derived quantities. Pressure is force by area, derived quantity. Power, work by time, again derived quantity. Charge is current into time, again derived quantity. So there are a lot of derived quantities, and your entire physics, you are just going to study these physical quantities throughout your physics. Electrical potential, capacitance, resistance, conductance, magnetic field, magnetic flux, inductance. You can see so many quantities are there. Got it, my dear warriors? Don't worry about all these things. I'm just giving you an example that this is what you're going to learn throughout physics. Shall we solve some questions? Ready for the first question on your screen? Ready for the first question on your screen? Yep. Very good. Awesome. It's raining everywhere. Chennai, Hyderabad, Bangalore. I can confirm that. Okay, near my house too. All right, my dear warriors. So time for the first question on your screen. Which of the following is not a fundamental quantity? Which of the following is not very fundamental? Come on, put up the answer in the chat box quickly. Okay, come on, my dear warriors. Waiting for your chats. Quickly, let me know the answer in the chat box. What do you think it is? Is it A, current? Is it B, come on, distance? Is it C, which is heat, or D, which is temperature? Everybody saying C. Oh, is it just C? No, it is not C. It is C for Captain Shreyas. It's not just C, it's C for Captain Shreyas. Hopefully, yes, it is C for Cap2. C for Captain Shreyas. Perfect. Not a fundamental quantity. Current is a fundamental, it is not derived. Charge is a derived quantity. Distance, length, definitely fundamental. Temperature, I just told you, temperature, degree Fahrenheit, Celsius, however you measure it, is fundamental. Heat depends on other things. So guys, it is a derived quantity, not a fundamental quantity. Question was not a fundamental. Not, that word not is very important. So this was level 1. I think that level is not seen. I think somewhere over here. I think next time I should put it on the top. It is getting hidden over here. I think so. Yeah, it is hidden. Basically, I'll show you what has happened. In the PDF, it will come because these things are there. It is not being shown. So this is the actual Google slide. So which I make it into PDF and share it with you. So over here, if you see, it shows as level 1. Now what is happening is when I use this note, so all those things are getting hidden. So when you get the actual PDF, then you will probably see level 1, level 2. Next time I'll make sure that this is written over here. I just realized it is getting hidden. Okay, cool. So don't get scared. Sir did not solve level 1, level 2, level 3. Oh my God. Okay, it will be seen later on. All right. Moving on now to units part. Why not A? I just told you right over here. What are the fundamental units? Fundamental units: current. These are assumed to be the fundamental. Everything else can be dependent on it. Like for example, you can see over here charge. Electrical charge is current multiplied by time. Charge is a derived quantity. Got it? Okay. Not current. Current is assumed to be fundamental. It's just by convention, by history. Yeah. I can actually move it. Is that? I don't know how I can move it. I don't want to waste the time over here now. Okay. So not sure how to move this. Okay. Anyways. Okay. Let me not waste my time over there. Okay. So what is this unit? If I tell you, let's take somebody's example. Who is it? Shirish. Shirish, what is your mass? So Shirish says the mass of Shirish is 40. What comes to your mind? 40? Anything? What is that 40? You need to tell me. Grams, kilos, tons. So, Shirish, if somebody asks you your mass, you won't just say 40. They will think maybe Shirish is 40 tons. Somebody else will think maybe Shirish is 40 grams. Some other person might think, oh, Shirish is 40 quintals, 40 pounds, 40 kilograms. Confusion. So you always need to give units. Yeah, it could be kg, or maybe he might say, no, my mass is in pounds. Anything, but you need to give something in front of it. That something in front of it is basically called as the unit. So if I say mass is 40 kg, or if I ask height, whose height shall we take? Whose height shall we take? Soumya. Soumya, what is your height, Soumya? Soumya says, sir, my height is 170, sir. I will be like, 170 feet. Oh my God, you are like Qutub Minar or that Leaning Tower of Pisa or what? No. So then Soumya will say, no, sir, it was in centimeters. Okay, fine. It is in centimeters. So that centimeter is the unit. So guys, this is nothing but your value. This is nothing but your unit. Same thing. This is nothing but the value or the magnitude, also you can call it magnitude of the physical quantity. And this is again the unit. This is our physical quantity. So in general, any physical quantity is the magnitude, is the magnitude, or whatever you want to call it, the value times the unit, times the unit. Symbolically, you will write it as physical quantity. Magnitude is generally symbolized by the number n. N is that value, that number which comes over here, 40, 170. Unit is having the symbol U. So physical quantity is N into U. This is a standard formula which you should know. N into U. Is this absolutely clear, my dear warriors? What is this formula and what does it stand for? Any physical quantity is magnitude times a unit. Correct. Very good. Oh my God, really, Soumya? Your height is 170. What a guess. I thought it will be, I just chumma guessed it. My height is like 176 or something. So I thought, okay, somewhere around only humans will be. So I took a whole number. Very good. So my prediction works every time. And you will notice that as you study more from me, whatever Shreyas Sir predicts comes in the exam. It happened in the mains, it happened in, even in advanced. Some 2, 3 questions came in JEE advanced. Okay. So anyways, coming back, are there physical quantities which do not have only any unit? Come on, let's see if you guys can figure this out. Are there physical quantities which do not have any unit? Are there any physical quantities without unit? Without unit. Come on, let's see. If you can answer this, I will be really, really happy with this. This is level 1 question. This is a basic level 1 question. Come on. Oh, Vishwa, no problem, Vishwa. Thank God this is an online class. Angle, no, angle has unit. What are you guys saying? What are you guys saying? Oh, come on, come on. Angle is having unit. So when I say theta is 90 degree, what is a degree? It's a unit. Or when I say, sir, the angle is, pi radian. What is that radian? It is also unit. So it has units, guys. That is wrong. Angles have units. Yeah, there are many things. Somebody saying current. No, 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 no. It is not current. You will learn that there are many quantities which do not have unit. Best example, which everybody will know because 10th standard you have passed, no? Everybody here passed 10th standard, pakka. So do you know this quantity called mu, which is your refractive index? Refractive index? Yes, that has no unit. What is refractive index measured in? I can't think, I can't remember, nothing. It does not, it's not written in terms of any unit exactly. You also might have learned of this term relative density. Relative density, or basically specific gravity. Specific gravity. It's the density of that object upon density of water. So if I measure density of water in some unit, same unit come here, they will cancel and it will be unitless, completely unitless. Yes, you will also see some more quantities like strain. Strain, you will see it later on. Don't worry about it. So where did it come from? Strain is basically how much is the change upon how much is the original quantity. The change in the length upon the original quantity, it is again unitless. Correct. Refractive index, even magnification. Correct. Very good. Even you will see relative permittivity, relative permeability. Yes, density is derived. Even you will see coefficient of static friction, kinetic friction. No unit for that again. So there are things. Basically, you should know that there are things which do not have units. Okay. Akriti, good evening. Join in little bit late, guys. Yep, perfect. So now, when I say units, think about it. Think about it, guys. If I define the units, I will come to that meme shortly. I know you guys are thinking, sir, what was that meme? Please show me. Hold on. If I define the units for fundamental quantities as well as the supplementary quantities, don't you think I define the units for every single thing? If I know the units for these and these, because everything else is derived from this, I have then got the units for every single thing. So we have to know now what are the units for every single fundamental quantity. Exactly. So for length, usually we use meter. Might be like, sir, what is a meter? The definition of a meter is very complex, but you don't have to know it for your JEE. Okay, you don't have to bother about it so much. But actually what happens is, 1 meter is 1,650,763, which is basically, I think, yes, it is 16,50,763.73 wavelength in vacuum of radiation, corresponding to the transposition between the levels 2p10 and 5d5 of the krypton 86 atom, or the distance traveled by the light in vacuum in 2 lakh 19, or sorry, even more than that, 299,792,458 second. That is called as a meter. That's how meter is defined. For us, we are like, sir, I thought meter was just to get a scale, sir. You measure from here to here, that is a meter. But the problem is, you cannot just say from here to here is 1 meter, because what is that here to here? How do you know somebody else will not measure it slightly differently? So it has to be in such a way that it does not change with time, with space, with pressure, with temperature, and all of that. Or else, everybody could say, the length of Shreyas Sir's hand is 1 meter. Tomorrow, Shreyas Sir grows old, the hand becomes long, everybody will go crazy, the length will change. I can't say the foot size is 1 foot exactly. No, that is wrong, because it will change with time. I will age, people will age, right? You cannot replicate, you can't carry my hand or foot everywhere and you're like, okay, sir, we need to measure 1 meter, sir, please get your hand. This is done in laboratories. This is done in proper setups to exactly measure 1 meter, and that's how they calibrate manufacture scales. Same way mass also has been defined, same way time also has been defined. So there is a nice long definition of how these units come. That is a separate class altogether. Let's not get there. Main thing what you should understand is whenever we define units, it should be easily reproducible. It should not change with time and other external factors. It should be constant. It should not change because of something else. So these things, when they are check mark, checklist is like okay, 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 that's when you can define the unit in that particular fashion. So my dear warriors, there are many other units of length, by the way. I don't know how many of you knew this. Light year is also a unit of length. Light year is also a unit of length. Sir, who will define 1 meter? Very good, Karthi. Who is going to define 1 meter? This 1 meter was defined by the scientific community, not by me, not by your teacher, not by your school principal, not by NTA person. There was a scientific committee which was formed. They did a lot of experiments, and they're like, okay, every time this is not changing, everywhere this is same, it is constant, I can reproduce it. So they defined a meter, a kg, a second, and other things. Okay, that's the scientific community. Remember that. Yeah, 1 light year, it's like crazy. Is the distance traveled by light in 1 year. It's crazy. I mean, light travels, just visualize this. 3 lakh kilometers in 1 second. Your bloody car, even if you buy a nice BMW or Mercedes or Audi or Lamborghini or Ferrari, Porsche. Okay, I don't want to talk about Porsche. Porsche is these days, okay, in the news. Okay, you talk about Lamborghini, whatever. Sir, it travels 350 kilometers per hour, sir. Per hour, how many per second? 350 kilometers in 1 hour. I'm telling you, light travels 3 lakh kilometers in 1 second. That's crazy, insanely large speed. And imagine that goes on for 1 year. It goes on for one complete year. Yes, Madhumita, will come to errors also. So that is a light year. And other units are also there. You should just know about it. Astronomical unit is the distance between sun and earth. Okay, parsec is the distance which this, one astronomical unit subtends an angle of 1 arc second, or basically 1 by 3/60th of a degree. So basically, if this is the sun and this is the earth, this is the earth. So if you are standing here, this is the angle subtended. If you stand little bit far away, this is the angle subtended. So you stand so far away that the angle subtended is basically 1 by 3600 of a degree. That distance which is there is called as a parsec. That distance which is there is called as a parsec. Okay, so this is how these things are being defined. You just have to have a slight idea about it. Okay, very good. Vishwa, yeah, even I am very poor in essay writing, so that's why I do not buy such cars. You know what I mean? All right. Chalo. Let's go to the next thing and let's see what are the different systems of units. Different parts of the world, people have their own convention, right? We have their own convention. So most of the people around the world use MKS. That means they measure length in meters, that's M, mass in kilograms, that's that K, time in second, that is that S in that MKS system. Got it, my dear warriors? MKS. MKS system is what is widely used. But Britishers, they are crazy. They use foot, pound, and second. So Britishers, they measure length in feet. The swimming pool is 16 feet deep. Your height is 5 feet. Even we use it because we are ruled by British. Mass is measured in pounds. Thankfully, we don't use pounds. It's crazy. Time is in seconds. Then there are another bunch of people who use CGS. I don't know why so many systems. Chumma. Length is in centimeters. That's the C. Mass in gram, that G over here is that G over here. Time is in seconds, that is that S in that CGS. So CGS, MKS and FPS, these are the three widely used systems. You can also make your own system. Nobody is stopping you, but it will not be printed in the textbook. That is the problem. Okay, so these are the three widely accepted. Out of that, MKS is more widely used and more natural to use. Why is it more natural? Because, yeah, you can have your own Pandu unit. Because it's very simple, yeah. 1,000 meters is 1 kilometer. 1/1000th of a meter is a millimeter. 1,000 grams is 1 kilogram. That's how it is. In FPS and all, it's crazy. 3 feet is 1 yard. Some number of yards is, 1 furlong. Some number of furlongs is some 1 mile. It's a crazy system. That's the reason why we do not use it so widely, but Britishers love it. Okay, so length, meter, kilogram is mass, time is second. But the problem is, these three are not the only fundamental units. There are more fundamental units, correct? Yes or no? There are more fundamental units. So if I extend it further, the MK system for the remaining four, fundamental quantities, then the MKS plus that additional thing is called as SI system of units. What is it called? SI system of units. So MKS is a subset of SI system. MKS is a subset of SI system. So when you write it down for all the units, fundamental quantities, length, mass, time, obviously the first three. Apart from that, current, temperature, light, and amount. So length in meters, mass in kilograms, time in seconds, current is in amperes. A is the symbol for that. Like seconds has S, kilogram has kg, meter has M. Temperature is in Kelvin, not in Celsius nor in Fahrenheit. It's a new scale which is called as the Kelvin scale. The symbol is K. Intensity of light, candela, symbol is CD, and amount of a substance is measured in mole, MOLE, and you will learn that in mole concept, which is MOL. That's the shortcut. Okay, everyone with me? Hello, Parishad? Yep, very good. Very good. Awesome. And for the plane angle, it is a radian. For solid angle, it is steradian. It is steradian. Okay. SR is the symbol. Radian, RAD is the symbol for it, or the shortcut way of writing it. So all these things you should know. The fundamental quantities in SI system, what is it measured in and what is their symbol, be it for the original 7 or the 2 supplementary units. And you should know that SI system is a superset of the MK system. MK system is only limited to length, mass, and time. The other 4 quantities with the supplementary units, if you involve them, that becomes your SI system of units. That becomes your SI system of units. Is this point clear, everyone? Very good. Excellente. Excellente. Perfecto. Perfecto. Okay. Now, remember, you can also change from one unit to the other, and you should know some basic conversion factors. Like for example, say you talk about grams, G. When I write kg, it is basically 10 to the power 3 grams. That K stands for 10 to the power 3. These are your prefixes to go from one to higher or lower unit. Then you also have small m into G, that is milligram, that is 10 to the power minus 3. 10 to the power minus 3. You can also write micro G, which is 10 to the power minus 6. Then you also have n small g, which is 10 to the power minus 9. Then you also have pg, that p stands for pico, which is 10 to the power minus 12. These are your prefixes. You also have fg, which is 10 to the power, I just don't have much space, but still I'll write it, 10 to the power minus 15. So guys, what are these things called? This is basically your milli, this is basically your micro, this is basically nano, this is pico, and this is basically Fermi, or sometimes also called as femto. So these are your lower units. You go smaller and smaller and smaller. So milli, micro, nano, pico, femto. -3, -6, -9, -12, -15. You can go higher. These are bigger units. Okay, or bigger prefixes. After kilo comes mega. Comes mega. So that is basically 10 to the power 6. Okay. Then you have giga, GG. All these are capital symbols. 10 to the power 9. Then you have TG, which is 10 to the power 12. 10 to the power 12. This is basically your kilo. This is basically your mega. This is basically your giga. This is basically your tera. Kilobyte, megabyte, gigabyte, terabyte. That is how it goes. KB, MB, GB, TB, right? Hard disk sizes. Everybody knows this. So this is how it goes. Everyone till this point, very, very clear, my dear warriors. Awesome. So these are basically your prefixes to go below smaller units or larger units. You should know all these basic things. Okay. And other things also, like standard conversion factors, you should know, like 100 centimeter is basically 1 meter, right? If you go to mm, instead of g, if I put m, millimeter, it will be 10 to the power -3 meters. So standard things you should know. Even speed conversion formula, like if I know it in kilometers per hour, if I know it in kilometers per hour, so 1 kilometer per hour is 5 by 18 meters per second. 5 by 18 meters per second. So some basic things you will learn as you go progress ahead. Okay, and we'll learn more and more physical quantities. So what is happening in these things is that this is a different unit, this is a different unit, this is a different unit. So the number changes. Do you see the number has changed? That is exactly what I'm talking about over here. Here the number is 1, the unit is U1. Here the number is 2, the unit is U2. But the quantity is the same. So N1 U1 is N2 U2 is a very, very standard relationship which you should know. Basically, the numerical value might change if the unit changes. If the unit changes, the numerical value might change. You can see that here also. N1 U1 is N2 U2. The numbers are different, units are different. Got it? Clear? Okay, we'll come to dimensions, Parishad, in a bit. We have not yet talked about dimensions. First, let's complete units. The SI unit of momentum, which is mass into velocity, is, think about it. Can you get the momentum's SI unit? Okay, I think you can. Come on, this is I think it should be a level 1 question only. Or, yeah. Momentum is mass into velocity. How is mass measured? Mass is measured in SI units in kg. Velocity is displacement by time. Displacement is measured in meters and time is measured in second. So the momentum will be measured in kg into meter per second. Kg meter per second. That's option number D. D for IT Delhi. Let's see if you guys have written it down. Very good, Harshika, Farisha, Goabi, Hanuma. Very good, Naisri, Hariharan. Very good, ABD. Awesome, Avanashri. Very good, Swati. Awesome, Kumari. Very good, Vignesh. Next question on your screen. Next question on your screen. The following two statements are given. I think this is a level 2 question. Okay, I'm guessing. Statement 1 says astronomical unit, parsec and light year are the units of measuring distance. Statement 2 says AU is less than parsec is less than your light year. What do you think is the correct option? What do you think is the correct option? Okay, think about it. This is a statement based question. We just did one slide over there and I told you just vaguely remember what it means. Just vaguely remember what it means. Then you can definitely solve it. Okay, let's go back to that slide. Let's go back to that slide so that you remember what these things were. Astronomical unit is the distance between sun and earth. Obviously, it is not going to be 1 light year. 1 light year is huge. The distance traveled by light in 1 year. Light reaches the earth from the sun in 8 minutes. So obviously, astronomical unit will be much lesser than 1 light year. That is so for sure. Parsec is the distance where the angle subtended between Earth and the Sun is, 1 by 3,000th of a degree. That is 10 to the power 3 kilometers, 13 kilometers. It's more than a light year. It's more than a light year, guys. So now you know whether this is true or false. Whether this is true or false. I think this is false. Obviously, the parsec should have been the largest. Light year in between. AU, which is the astronomical unit, should be the least. So guys, statement 1 is correct. Statement 2 is definitely not correct. Correct? Everybody understood this? Very nice. Option C. Very good. Very good. So this was a level 2 question. Sometimes they ask you from NCERT. So please read NCERT and go. You cannot skip NCERT and expect that you can solve it. Now, any physical quantity I give you, you can always find the unit of it. It's not that difficult. If I tell you, see, there is a term called as energy density, which is energy per unit volume. Energy per unit volume. U is energy and V volume. Energy is nothing but measured in joules. Is measured in joules. Volume is nothing but measured in meter cube. So the unit of energy density be joules per meter cube. As simple as that. You tell any physical quantity, if you know the formula, you can always get the unit. For example, the gravitational force is given by G m1 m2 divided by r square. What is the unit of G? So write down, therefore, G is equal to force into r square divided by m1 m2. So guys, now you know what should be the unit of G. Force is measured in Newton. Distance is measured in meter. Mass 1, mass 2. So this is kg into kg. So that will become kg square. Kg into kg will become kg square. So the unit of G is Newton meter square, because this was r square. Newton meter square per kg square. Newton meter square per kg square. Got it? Everyone, how this works? If you know the formula, you can get the units. If you know the formula, you can get the units of any goddamn physical quantity. So don't have to worry. Now let's come to the next part of the chapter, which is called dimensions. And I hope you are understanding everything with the flow, and I hope the speed is right, and I hope you guys are, enjoying the class too. Yep. So let's talk about dimensions. Now, you take any physical quantity. If it is a derived quantity, I will write it in terms of the fundamental quantities. When I express it in terms of those fundamental quantities, maybe the powers of those fundamental quantities could be anything 1, 2, 3, 5, minus 1, minus 2. When I write it in that form, when I express a derived quantity as fundamental quantity with suitable powers, that is called as the dimension of the physical quantity. So say for example, very simple example I give you, very, very simple laddu example, volume. Volume is basically length into breadth into height. Whenever I want to express dimensions, the way to show that is by putting square brackets. So when I write dimensions of volume, I will put square bracket volume. That means I'm interested in the dimensions of it. So I will just put L into B into H. Dimensions of L into dimensions of B into dimensions of H. What is length measured in? It is measured in length only. What is breadth measured in? It is fundamental quantity. It is measured in length only. Height is also measured by measuring the length between two different points. So basically, it is nothing but length into length into length 3 times. So length raised to 3. So the dimensional formula for volume is length raised to 3. The dimensional formula for volume is the length, which is fundamental, raised to 3, because all the three things are measured in terms of the length. But writing this length every time is a very lengthy process. So the short form for length is capital L. I can put this square brackets, I can put this over here. If you see this over here, L cube and then square brackets, it's one and the same thing. Don't get confused. Don't get scared. Okay. This is perfectly normal. You put 3 outside or 3 inside, it's one and the same thing. So I can say the dimensional formula for volume is L cube. The dimensional formula for volume is L cube. As simple as that. So every fundamental quantity has their own symbols. Where is it? I think I did not put it. Okay. So let's go back over here. Yeah, let's write down the dimensional formula over here. What is the dimension? What is the dimension of all the fundamental quantities? What is the dimension of all the fundamental quantities? Okay, come on, guys. Length, the symbol for that is capital L. The symbol for that is capital L. For mass, the symbol is capital M. Okay, dimensions, guys. This is length, this is mass. Then for time, it is basically written down as capital T with square brackets to symbolize dimension. Electric current is symbolized with capital A, same as the one in units with square brackets. Thermodynamic temperature, that is a temperature, it is measured in Kelvin and the symbol dimensionally is also capital K only. Intensity of light is basically capital C small d, okay, with square brackets. And quantity of a substance, again over here, capital M OL. You can't use M because M has been used by mass. So that's why you put MOL over here. That's all. These are the dimensional formulas of all the 7 physical quantities. Now, I want you to tell me what is the dimensional formula for the plane angle and the solid angle. If you answer this, this is level 2 question, guys. If you answer this, I'm really proud of you. Really proud of you. Come on, guys. Plane angle and solid angle, what is the dimensional formula? What should I put over here and over here? What should I put over here and over here? Come on, guys. Let's see if you guys can figure this out quickly in the chat box. Quickly in the chat box. Yes, Siva Prasad, I know the final answer key came. Very good, Soumya. Very good, Avanishri. Very good, Sumant. Very good, excelente. Hariharan, December 2024 is too late. We will complete the entire syllabus much before that. Much before that. Yes, they are dimensionless. They are dimensionless. So a lot of people think if something has a unit, it has a dimension. Wrong. This is the best example for that. Just because it has unit does not mean it has dimension. It is a completely dimensionless thing. I will prove this to you. What is the formula for the length of the arc? Length of the arc is radius into theta. So the dimensions of length is the dimension of arc into the dimension of theta. So the dimension of theta is the dimension of the length of the arc. Dimension of the length of the arc upon the dimension of the radius. Length of the arc is dimensionally capital L. Radius is also length, so it is again L. L will cancel. What will you get? Nothing over here. So guys, theta is completely dimensionless quantity. Same thing for solid angle also. Same thing also. Okay, everyone with me on this? Perfectly clear? Very good, very good. Awesomeness. So guys, let's move back to our slide. Okay. I think this we had seen before. I don't know why it came over here. My bad. Yeah. So you have seen the dimensions of anything. Now, how do we calculate dimension? How to find dimensions? How to find dimensions of any quantity? There are two ways. First way, if you know the formula, if you know the formula. The second way, if you know the units. If you know the units. If you know either one of this way, then you can follow that method to find the dimensions of any physical quantity. For example, my dear warriors, I want to know the dimensional formula for acceleration. Acceleration is nothing but, velocity divided by time, actually change in the velocity divided by the time, right? So I'll put a square bracket over here. Don't worry, we'll learn about acceleration later on also. Velocity, velocity is actually displacement divided by the time. And this time is also here. So now, technically, displacement is there on the top and square of the time is there below. Displacement is measured in length and time is measured in t. So t square. So technically, the dimensional formula for acceleration will be length raised to 1, t raised to minus 2. Mass is there, nothing else is involved. Nothing else is involved. Got it? That's how you can find out the dimensional formula if you know the actual formula of that physical quantity. Same way over here. If I know the units also, I can find it. Example, there is a physical quantity whose dimensions is kg square meter cube per second. What will you will think? If the unit is kg square meter cube per second, meaning the mass dimension is having the power 2. So it is basically m raised to 2. Meter, length unit is cubed. So the length dimension will also be cubed. Time is there below. So it is actually time raised to negative power 1. So hence the dimensions of this would be m raised to 2, l raised to 3, t raised to minus 1, which is very, very easy to find. Very, very easy to find. Yep. Is this very, very clear? Shirish, only PYQs will not be completely enough. I think you have to push yourself ahead. Just PYQs is decent, but I mean, just to get till probably 98, 99 percentile, if you want to go beyond 99 percentile, you have to stretch a bit further. Fair enough. Let's do some questions. I think these are level 1 or level 2 questions. Okay. So one is knowing the formula. Second one is knowing the units. So let's see if you guys can quickly figure this out. If I tell you the force is equal to 6 pi eta r v, find, okay, let's do one thing. Let's solve it simply first. Find the dimensions of force first. Okay, then find the dimensions of work. Okay, then find the dimensions of power. Find the dimensions of power. Okay, then I want you to find the dimensions of momentum. Okay, all these things I want you to find. I'll give you the hint. Force is mass into acceleration, standard formula. Work is force into displacement, standard formula. Power is work by time, standard formula. Momentum is mass into velocity. Very easy to find out the dimensions now if you know this. Very easy if you know the formula. Come on, my dear warriors. Come on, my dear warriors. Pacha, I am over here, so it's very difficult for me to go on both the channels, but please understand. Yes. Okay, let's start. Force is mass into acceleration. So it is m into a, and mass is measured in capital M. Acceleration unit wise is meter per second square. Meter is length per second square. So t raised to 2. That's what it is. So if I write it in a very systematic form, m raised to 1, l raised to 1, t raised to minus 2. Very good. So m raised to 1, l raised to 1, t raised to minus 2. Work. Work is force multiplied by displacement. Force, we just solved over here. It was just solved over here. M raised to 1, L raised to 1, T raised to minus 2. Displacement is length. So I have to multiply length with length. So M raised to 1, L1 and L1 over here will make it L raised to 2, T raised to minus 2. That is the dimensional formula for work. Power. Power is work per unit time. Work per unit time. So work is this, which is basically M raised to 1, L raised to 2, T raised to minus 2, whole thing divided by time, which is basically T. So guys, this is going to be M raised to 1, L raised to 2, T raised to, what will happen? It will become T raised to minus 3. How many of you wrote it? T raised to minus 3. Very good, GG. Oh, it's not GG. Oh, so sorry. It was JEE. My God. Don't put it like that. Okay, momentum is mass into velocity. Mass is measured in mass, capital M. Velocity meters per second, length per unit time. So therefore, M raised to 1, L raised to 1, T raised to minus 1. That is the correct answer. Got it? That's how you can find out the dimensions of any physical quantity if you know the formula. Similarly, if you know the units also, you can do it. Let's say, for example, kg inverse meter per second cube. What is the dimensional formula? Next, ampere square into Kelvin per kg square. Okay, what is the dimensional formula? Come on, my dear warriors. If you know the units, also you can get the dimensions. If you know the units, also you can get the dimensions. Come on. Yes, this will be kg inverse. It means it is m raised to minus 1. Meter is basically length. And second is time, but it is below. Bring it on the top, it will become t raised to minus 3. Time raised to negative. Very good. Here, this is ampere. Ampere is A only, A raised to 2. This is Kelvin, is temperature. So it's just K raised to 1. Kg is below. So it is mass raised to negative power 2. It was there below. So that's why negative power. Got it? Straightforward. As simple as that. Very nice. Let's solve this next level of question which was asked in JEE Mains. Okay, next level. Okay, so physical quantities and their dimensions. Now I'll tell you, if you know the formulas, you can get it easily. If you know the formulas, you can get it very easily. So I will tell you what the formulas are. I'll just duplicate this couple of times and I'll show you. It is very straightforward. So guys, let me tell you, Young's modulus is basically force by area upon change in length by original length. This is the formula for Young's modulus. If you talk about viscosity coefficient, use this. Force is 6 pi eta r v. Therefore, eta is basically force by 6 pi r v for this one. For Planck's constant, use energy is equal to h into F. So h is basically energy by frequency. For work function is basically just energy. So it is just basically same as energy, which is same as work. Same as work. Okay, so dimensionally it is same as work because work function is just the energy required. So it is dimensionally equivalent to work only. Now, if you know the formulas, it becomes easy. You're like, sir, I don't know these formulas yet. That's what I'm trying to say. You will learn these formulas later on. So, for example, for work function, it is dimensionally like work. It is dimensionally like work. So, what is the dimensions of work? We just did it some time back. Right over here. M1 L square T raised to minus 2. That was the dimensional formula for work, right? So that's it. It's just going to be mass raised to 1, length raised to 2, T raised to minus 2. Is it there? M raised to 1, L square, T raised to minus 2. Yes, it is there right over here. It is there right over here. Everybody with me? D is going with 4. Same way. Yes, it is same as energy. Energy, work, everything. E is equal to hf. It is basically energy by frequency. So guys, energy is same as work. Energy is same as work. Frequency is 1 by the time. So energy is same as work, means m raised to 1, L raised to 2, T raised to minus 2. This is 1 by T. So time goes on the top. What will happen? You will get m raised to 1, L raised to 2. T with minus 2 will make it minus 1. So T raised to minus 1. M1L square, M1L square, T raised to minus 1. So this goes over here. This goes over here. Work function was over here. Is that clear? So similarly, you can solve it for the others. Like for example, if you solve it for this guy, force has the dimension of m1 L1 T raised to minus 2. 6 and pi are dimensionless. R is radius, which is length, and velocity is length per unit time. So T raised to minus 1. So what will happen? See this, m raised to 1. This L and this L got cancelled. One L went on the top, became L raised to minus 1. This minus 1 and minus 1 cancelled, so T raised to minus 1. So M1 L raised to minus 1, T raised to minus 1. So this is basically this. This was this. This was this. Naturally, the remaining one will be for the third one. So as simple as that. This was going with this. This was going here. This was going here. So naturally, this will go over here. That's it. As simple as that. Using this formula also, you'll get the same thing. Got it? How we use the elimination method to solve this as the following question. Okay, the answers are mentioned here. Exactly. A is going with 3, B is going with 1, C is going with 2, and D went with 4. Perfect. We solved it. Moving on. What is the significance of dimensions? Very straightforward. 3 uses only: to verify the correctness, second, to derive a relationship, third, converting units from one system to other system. What it means, I'll explain you in detail. We use dimensions for checking correctness of an equation, sometimes even for eliminating options. You can also use it for deriving relationships. And the last one is to convert from one system of unit to the other system of unit. Let's talk about the physical correctness first. Tell me, is this okay? The dimension of length multiplied by the dimension of mass is actually m raised to 1, L raised to 1. Is this correct? Yes or no? Quickly tell me. Yes, it is. What about this? M raised to 1, L square divided by m square into is basically just like normal division. It will be m raised to minus 1, L raised to 2, T raised to minus 1. So you can multiply one dimension with next dimension. You can divide a dimension with the next dimension. What about this? Dimension of mass plus the dimension of mass. What do you think this will be? What do you think I will get over here? And similarly, tell me over here also. Dimension of length square T raised to minus 1 plus dimension of length square T raised to minus 1 minus a dimension of L square T raised to minus 1. What do you think I'll get over here? Or let's just use only one of them. That's also okay. What do you think I'll get over here versus here? Come on, my dear warriors. What do you think is the answer for this? Dimension of a mass plus the dimension of a mass. I will get dimension of mass only. A lot of people think there should be 2 over here or probably m square over here. No. When I add mass with mass, I will get mass. So dimensionally speaking, I'm still getting mass. So don't put 2m. Number 2, when I subtract this with this, I'm subtracting a quantity of certain dimensions with a quantity of same dimensions. I will get a quantity of those same dimensions. So it will be L raised to 2, T raised to minus 1 only. There is nothing wrong over here. right? So do not put 0. A lot of people put 0. So this minus this, you are treating it like variables. This is not x minus x is equal to 0 or x plus x is equal to 2x. No, these are not variables. That's what should get inside your head. These are the dimensions. I can add apples and apples together. 10 oranges minus 2 oranges will be 8 oranges. So it is talking about the type of the quantity. So the type of it, what is the 10 type? Orange. What is the 2 type? It is orange. What is remaining type? It is also orange. So when I put square bracket, it represents the type of that quantity, which is length, mass, time, whatever. But tell me this. What about this? Length plus mass. This is wrong, guys. I cannot do that. Even this L square m minus m t raised to minus 1. This is also incorrect because they are of two different types. Whenever two different types are there, I can't add them, I can't subtract. Basically, it is mathematically only wrong. It is mathematically only wrong. Keep this in mind. Yes. So, whenever I have an equation, whenever I have an equation and I put equal to, I have the left hand side, I have the right hand side. Now, on the right hand side, you might have physical quantity 2, physical quantity 3. Here also, some physical quantity 1, physical quantity 2, physical quantity 3, etc. This could be added, subtracted, I don't know. Something and all is happening. What should happen is the dimensions should be the same on the left hand side as well as on the right hand side. Such an equation is said to be dimensionally correct or dimensionally consistent. This thing is also called as your principle of homogeneity. 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 Homo means similar. Homo means similar. Yes. Homogeneity meaning similar dimensions only can be added or subtracted. It is illegal to add or subtract dimensions of two different kinds. Multiplication, division is perfect, no problem. The problem is only when it is added or subtracted. Shirish, dimensionless also. If one quantity is dimensionless, you can add and subtract only with a dimensionless number. You can't obviously add it with a number with a dimension. Okay, it is going to work for dimensionless quantities also. Now, how do we use this? Okay, so I have put up a question. I think it is level 1 question. It is again not seen in the PDF which you will get. You will see it. Okay, so look at this. X is equal to AT plus BT square, where X is distance, in kilometers, T is time, the units of A and B. Okay, actually, it should have been the dimensions of A and B are not the units. I wanted to put not units, the dimensions. The dimensions of A and B are. See guys, look at this equation. Look at this equation. X is equal to AT plus BT square. Left hand side, right hand side. Don't you agree? If an equation is given, then dimensionally it should be correct. So the dimensions on the left hand side and the right hand side should be matching. Not just that, not just that. Because few of the terms are being added or subtracted, few of the terms are being added or basically subtracted, I can also say each of these terms also have the same dimension, right? All of them have the same dimension. Now think about it and tell me, what is the dimensional formula for X? What is the dimensional formula for X, guys? Come on, quickly think and tell me. Yes, it is length. So L is also A into T. Also, length is B into T square. Nothing wrong over there. Each of these physical quantities will be equal to the dimension of length. X is in distance. So distance is in length. Exactly. So now think, Whenever quantities are multiplied, no issues. Division, no issues. Dimensions also get multiplied and divided accordingly. So A into dimension of time over here. So that is L. Therefore, what is the dimensional formula of A? It will be, take time below, L raised to 1, T raised to minus 1. That's the dimensions of A. Similarly, about B over here, this is dimension of B into dimension of T square. This is dimension of length. So the dimensions of B are length raised to 1, T raised to minus 2. Length raised to 1, T raised to minus 2. Yes, equal to the dimension of BT. Yes, yes, Shirish. All these three dimensions were equal. All of them should have the same dimensions of length. That's what I mentioned over here. All these three. So the dimensions of X will be the dimensions of AT, which is equal to the dimensions of BT square, which is the dimensions of length, because they are being added or subtracted. It has to be equal. Yeah. Dimension of time is t. Yes, correct. Very good. Shall we go to the next question? I think this is the level 2 question. Let's see if you guys can figure this out. Find the dimensional formula for alpha and beta. This is next level problem, guys. Okay. This is the next level problem. Let's see if you guys can figure this out. I think it was some level. Let's see. Where did it go? Yeah, this was that. I think it was right over here. Yes. Level 2 question. Wow. Level 2 question. Cool. Let's see if you guys can figure this out. Come on, my dear warriors. In this particular equation, this guy, and this guy added, subtracted, left hand side, right hand side should have the same dimensions. So very quickly, alpha by t square should have the same dimensions as force into velocity, should also have the same dimensions as beta by x square. I think let's take it part by part. If I take these two together, the dimensions of alpha by the dimension of time square will be the dimension of force. Force dimension is m raised to 1, L raised to 1, T raised to minus 2 into dimensions of velocity, L raised to 1, T raised to minus 1. Take time square on the top. Therefore, alpha will have the dimension of, mass is not there anywhere else except for here. L is there here and here, so it will become L square. T raised to minus 2, T raised to plus 2 will cancel. Only this one negative power will remain. So that is the dimensional formula for alpha, just looking at these two. Now, just look at this and see what do you get. Just look at the second and the third one. Dimension of force is mass raised to 1, L raised to 1, T raised to minus 2. Velocity is length raised to 1, T raised to minus 1. Is the dimension of beta, which I do not know, upon x. X is basically length, so length square. So therefore, beta's dimension will be, mass is there only one time, so m raised to 1. L raised to 1, L raised to 1, L raised to 2 will become L raised to 4. Minus 1, minus 2 will make it minus 3. That's it. That is the dimensional formula for beta. We got it. How many of you got it? Avanish, got it? Very good. Anand also got it. Bala, wow, very good. M L square T raised to minus 1, very good. Sir, in case of dimension of force equal to alpha equal to velocity equal to beta. No, Shirish, I hope you guys got it. It is, this whole ratio will be equal to force into velocity, which is also equal to beta by x square. This number is added to force into velocity. So this ratio will have same dimension as force into velocity. Same thing over here on the left hand side. Cool. Is this clear? Yes, take Fe and alpha by T. Yes, on one side and the other side. You can find beta through alpha also. Yes. Yes, you can find beta through alpha also. No issues. Yes. Yep. You can equate this with this because you know alpha from here. No issues. You will still get the same answer. Okay. So, Nikhil, what we just did, Just like in the previous problem, what did we do? This dimension is this dimension is this dimension. Like I said over here, this is this is this. Same thing over here. Alpha by t square, f into v, and beta by x square all have the same dimensions. So I took these two together. Alpha t square, force, velocity. Then force, velocity, beta, length square. You just have to take L square here, do simple maths. Here you just have to take time square on the top, do simple math, and you will get the answer. Cool. Simple power analysis. Yes, Vishal, on the in the jungle book you will get it, the DPP. Let's go to level 3. Ready for level 3? If you crack this, I am proud of you. If you crack this, I am really, really proud of you. I will give you the formula. Don't worry about the formula. Don't ask me, sir, I don't know the formula. I'll tell you the formula. The formula is force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is what it is. And charge is basically current multiplied by time, and energy is basically h into frequency, which is basically h by time. Okay, these are the formulas. Whatever formulas you need for solving the question, I've given. So the physics part, formula wise, is over. Now you just need to use your units and dimensional analysis. Come on. Come on. Let's see if you guys can figure this out. Yes, Yurish, the answer for the previous question is correct. No issues with that. All right. So let's try to think about it. Let's try to think about it. Energy is there over here. Energy is nothing but force multiplied by displacement, and force is over here. Interesting. Let's see if we can do something about it. Let's see if we can do something about it. So guys, observe this carefully now. Energy is same as work. Work is force into displacement. Force is this one, which is, oops. Force is basically 1 by 4 pi epsilon naught Q1 Q2 divided by R square. That is the force into displacement, which is S, is equal to the energy, which is H divided by time, because it is HFF, frequency is 1 by time. Okay. Now the question is, something and all is given. You want to get a dimensionless quantity. You want to somehow get a dimensionless quantity. Let's try this out. What I feel over here, let's take 4 pi. Do you see 4 and pi? These are pure numbers. Do they have any dimensions? No, right? They don't have any dimensions. Let's take 4 and pi on the other side. Rest everything on this side. So I will have Q1, Q2, Q1, Q2 divided by R square into S into T divided by H. Okay. And also epsilon naught from here is equal to 4 pi. Now charge is current into time. So dimensionally speaking, this is current multiplied by time. This is also current multiplied by time. This is displacement and this is time. This is R square H epsilon naught is equal to 4 pi. Everybody fine till this point? I've just written charge as current into time. S is there from before. Time went on the top. H came below. Epsilon naught and R square is there as it is. Now, this is level 3, JEE advanced question. We have to be very careful. Now, write down the dimensional formula of each and everything. So like, for example, this is current square. Time is there 3 times. So T raised to 3 is there. We also have displacement over here. We also have R square over here, H over here, epsilon naught over here is equal to 4 pi. So dimensionally speaking, dimension of current is ampere. So ampere raised to, then time is basically, oh, can I get rid of time also somehow? because time was not there over here, because speed was there. Oh, so I will get rid of it, no issues. This time which is there, this time which is there, this time which is there, guys, use this formula. Speed is distance divided by time. Therefore, time is distance divided by speed. Time is distance divided by speed. So I can just put over here distance is s divided by speed, which is basically c. So s cube over here, c cube over here. S cube over here, C cube over here, because T into T into T was basically T cube. So that T cube, I have written it down as S cube by C cube. Everybody fine? Why did I do that? Because I saw there was no time involved over there. Okay. So now, what else is there? What else is there? Yes, this is done. Perfect. Okay. One distance will still remain. One distance will, Planck's constant is there, epsilon naught is there, current is there. Yes. And okay, that S is there. Okay. So let's see. I think we should get over here ampere square. Perfect, no problem over here. Distance into distance, distance into distance is distance raised to 4. So length raised to 4 is over here. Length raised to 4 is over here. Okay. Then over here, r square and h. R is also length. R is also length. Okay. R is also length. So I will write down length raised to 2 over here. Length raised to 2 over here. H is as it is. H is as it is. I will leave it over here. H is as it is. I'll leave it over here. Oh, wait a minute. I didn't have to write in terms of current. I'll tell you why. I'll tell you why. Because this was e raised to alpha. This was e raised to alpha. E means basically the charge. So I don't even have to do all these things. Hold on. Let us come back. Let us come back over here. Let us come back over here. Let us come back over here. I don't even have to do these things. I can just write this force. I can just write this particular force as 1 by 4 pi epsilon naught. Charge has the same dimension as E. Charge, another one, also has the same dimension as E. And then I have R square. And then I have R square. Okay, perfect. Force into displacement is energy. Force into displacement is energy, and energy is h by t. Energy is h by t. So if I take this whole thing, and multiply by displacement, so 1 by 4 pi epsilon naught, charge 1, charge 2 divided by r square. I multiply it with displacement. I get energy, which is Planck's constant divided by t, which is Planck's constant divided by t. Okay, so now I have got E over here, I have epsilon here, I have H over there. I just don't have C right now. No issues. Just look at this. Dimensionally speaking, this is E square. 4 pi is a dimensionless number. Epsilon naught, I will just leave it as it is. Dimension of S is basically length. Dimension of R is also length, but square of it. H, dimensionally, I just leave it as it is. This is time, so dimensionally, this is basically T. So now, this is the dimensionless quantity which I am looking for. So just rearrange this. Observe. Observe carefully. Observe this carefully. If I shift it on the top, what will I get? If I shift it on the top, what will I get? I'll get E square. As it is. Okay, no issues. What else will I get? Length and length square, one of them will cancel. Only one length is remaining. Only one length is remaining. Okay, only one length is remaining. Perfect, no issues. Then epsilon naught is also remaining below. Epsilon naught is also remaining below. Okay, epsilon naught is also remaining below. Time is coming on the top, h is coming below. Time is coming on the top and basically h is below. H is basically below. This is what I get. Now observe this. What is length by time? Distance by time. It is basically speed. So it is e square. Length by time dimensionally is same as the speed, and this is epsilon naught, and this is basically h. So it is e raised to minus 2, c raised to e raised to plus 2, e raised to plus 2, c raised to minus 1, epsilon raised to minus 1, h raised to minus 1. This is that dimensionless quantity which I was looking for. So, in general, if I raise it to n, in general, if I raise it to n, what will happen? Everything will raise to n. So, it will become e raised to 2n, c raised to minus n, epsilon raised to minus n, h raised to minus n. I think I have got the answer. E's power is 2n. C's power is basically minus n. Epsilon's power is minus n. H power is also minus n. So 2n minus n minus n minus n. That is option number A. Option number A is the correct answer. Option number A was the correct answer. Okay. Why can't we directly apply the dimension formula of respectively? That will be much lengthier process. I see that when I write it like this, 4 and pi are dimensionless number. So that's the reason that 4 pi, I got it over here. That's the magic that we have done. This dimensionless thing, I got it over here. This h, I took it on the other side. Time also, I took it on the other side. That gives me the solution in a much easier manner, because everything was measured in terms of these quantities h, e, epsilon. Finding the dimension of epsilon h is much more difficult task. Yes. Okay, that's why it's a level 3 question. Moving on to the next type of problem, where you convert one physical quantity into other physical quantity. See guys, if you want, one physical quantity in one unit to another unit. I had just told you, when you change the units, what happens? You use the formula N1U1 is equal to N2U2. N1U1 is basically N2U2. This was the guiding force. This was our guiding formula. But just to give you an example, to convert from one unit to another unit, all you should know, you should know the conversion factors of the fundamental units and the dimensional formula If you know this thing and this thing, you can come from one unit to the other unit very easily. You can go from any unit to the other unit in very easy manner. I'll just show this to you. I want to convert 5 Newton into the CGS counterpart. Tell me, Newton is the unit of which quantity? Force. So, do I know the dimensional formula for force? Do I know the dimensional formula for force? Yes, it is mass raised to 1, length raised to 1, t raised to minus 2. Everybody with me? This is the dimensional formula. So you should know the dimensional formula to convert from one unit to the other unit. Next thing, you should know the conversion factors. I think that part I know, which is from CGS to SI system. One is SI units, one is CGS unit. So think about it. I think I know this. 1 kg is basically 10 to the power 3 grams. 1 meter is 100 centimeter. 1 second is 1 second only in CGS unit. This was CGS, this was SI. Correct? This was SI system, this was CGS system. You should know the conversion factors of each of the individual fundamental units. Okay, I know that. Now, how do you convert it? Simple. Observe. 5 Newton. Because a Newton has the dimension, or force has the dimension of mass, length, t raised to minus 2. If you write it in fundamental units, what will it be? A Newton will be 1 kg will be there, kg raised to 1. A meter will also be there, and second will be there below. Do you guys agree with this? Kg meter per second square if you convert it into fundamental quantities. If you write it into fundamental quantities. Perfect. Now, what is 1 kg? Look over here. 10 to the power 3 grams. Okay, perfect. 10 to the power 3 grams. What is 1 meter? It is 100 centimeter. What is 1 second? It is 1 second only. Ah, perfect. 10 to the power 3 into 10 to the power 2 is 10 to the power 5. So 5 into 10 to the power 5 gram centimeter per second square. That's it. That is the CGS unit, and that is called as a dyne. In CGS, the Newton is called the dyne. Okay, it is measured in terms of dyne, gram centimeter per second, which is the CGS unit. So that's it. I have converted the Newtons into the CGS counterpart. It is that simple. You just need to know two things. What are the two things? You need to know the dimensional formula, and you need to know the individual conversion factors for the fundamental units. That's all. That's all. As simple as that. CGS is gram centimeter second. Remember that? I just told you some time back. Any unit, any physical quantity you can convert, guys. For example, there is a physical quantity whose dimension is m square L by T square. And let's say there is a new Pandu unit. Okay. And in that Pandu unit, what happens is 1 kg is equal to 10 unit mass, 10 unit mass. 1 meter is, let's say, 2 unit length, 2 unit length, and 1 second is 0.1 unit time. 0.1 unit time. So think and tell me how much will be 10, okay, SI units, 10 SI units will be how much in the new units? Will be how much in the new units? That is the question. Will be how much in the new units is the question. The dimensional formula is given. Individual fundamental quantities conversion is also given to you. Okay, let's try to do this. First of all, what will you do? 10 SI units, meaning, first write down 10. What will be the SI unit of this physical quantity? Mass raised to 2. That means it will be kg raised to 2. Length is measured in meters. So meter raised to 1. Time is there below, second square. Kg square meter per second square. That is some new physical quantity. I don't know what it is, but it is some physical quantity. Now write down each and every single conversion factor. Starting off with kg. 1 kg is 10 units mass. So unit mass, 10 unit mass, and this is squared. So this is also be squared. Leave it. Meter. How much is a meter? 2 unit length. So 2 unit length. That's it. Raised to whole thing divided by second. 1 second is 0.1 unit time. 0.1 unit time. But raised to 2. All right. Let's see what do you get. I can see 110 is there. This 10 square is there. Into 2 is there. 0.1 square is there. 0.1 square is there. And we have unit mass square. unit length upon unit time square. This will be, come on guys, second one is 1 by 10. So square will be 1 by 100. So 100 into 10 to the power 2 is 10 to the power 4 into 10 is 10 to the power 5. So this will become 2 into 10 to the power 5. This will be the new unit. This will be the new unit. That's it. So 10 SI units is 2 into 10 to the power 5 new units. That's all. Is that clear? Is that clear, my dear warriors? Yep. Yep. Very good. Very good. What about SI unit? What do you mean by what about SI unit? SI unit is a system of units. For mass, you measure in kg, length you measure in meter, time you measure in second. So when they say that, this is Newton, it is an SI system. Okay. So understand that Newton only will be like kg meter per second square. If the reverse problem comes, that's what you mean. You will do the exact reverse process. You will do the exact reverse process. Then you will write 1 gram is 10 to the power minus 3 kg. 1 centimeter is 10 to the power minus 2 meters. 1 second is 1 second. So you'll just shift the powers over here. Then you will write 1 gram is how much, 1 centimeter is how much, and then solve the problem. That's all. Okay. Clear? Perfecto. Perfecto. Yes. Let's move on. Let's move on to the next question. Test dimensionally if this formula is correct or wrong, and force is F, X is distance, T is time. So this is checking your dimensional consistency. I think it is a level 1 or 2 problem. So check this out, my dear warriors. Is this dimensionally correct or wrong? We have to check the consistency. 2 and pi, dimensionless number. Okay, let's go with the RHS and LHS. So LHS dimensions will be the dimensions of time. So it should be just capital T. Let's talk about the RHS. The dimensions of RHS will be the dimensions of 2 pi into the dimensions of mass by force and divided by length, the whole raised to half. 2 pi is a completely dimensionless number. Forget about it. M is M only. Forget. This is raised to half, or let's just put a common power. So it is capital M. X will go on the top. It will become length. Force is basically M raised to 1, L raised to 1, T raised to minus 2. Okay. The whole thing raised to half. So this will become M cancels, LL cancels, T raised to minus 2. So it goes on the top, it will become T raised to 2 raised to half, which is just T. Oh, wait a minute, which is the same as dimensions of LHS. So this is a dimensionally correct equation. Nothing wrong with it. This is a dimensionally correct equation. Got it, my dear warriors? Everybody with me? Clear? Awesome. So this is how you check the dimensional consistency of any equation, by matching the dimensions or starting from one side and see whether it matches with the other side. I've solved many questions like this now. Next question. This is a level 2 question. A density of a material in SI system is 128. In some new unit where length is 25 centimeter and mass is 50 gram, the numerical value of density is how much? Okay. What did I tell you? To convert from one unit to the other unit, what should you know? The conversion factor of fundamental quantities. Second thing, the dimensional formula. These are the two things which we should know. Who do you have to convert? Density. So quickly think and tell me, what is the dimensional formula for density? Because it will be the dimensions of mass divided by the dimensions of volume. So technically it is m raised to 1, L raised to minus 3. That's the dimensional formula for density. First thing done. Next thing that I will need is individual conversion factors. Individual conversion factors. So think about it. Length is 25 centimeter in a certain unit where the unit of length is 25 centimeter. One unit length is 25 centimeter. But I don't want centimeter. This was in kg and meters SI system. So I need to do that conversion also. 25 centimeters is 1/4 of a meter. 1/4 of a meter. So if I take 4 on the other side, what will I get? 4 unit length. 4 unit length is 1 meter. That is the first thing that I get. I take 4 on the other. 4 unit length is 1 meter. Got the conversion factor? Till this point, everything clear? Next, unit of mass is 50 gram. 1 unit mass is basically 50 gram. 50 gram, 50 gram is basically 50 into 10 to the power minus 3 kg. I want kg, so I will shift it on the other side. But before doing that, 5 into 10 to the power minus 2 kg. Shift it on the other side. So 1 kg, take it over there. 10 to the power minus 2 will become 10 to the power 2. And that 5 on the top will come below. Unit mass. Unit mass. 10 to the power 2, 100. 100 divided by 5 is 20. So 20 unit mass, 20 unit mass is basically 1 kg. Till this point, is it clear? Very good. Awesome. Now just do the final problem. 128 kg per meter cube. 128 kgs per meter cube. I should know the dimensions, only then I can get it. I can get the conversion factor. So 128 as it is, 1 kg. 1 kg is 20 unit mass. 20 unit mass. Yes. Divided by meter. A meter is 4 unit length. 4 unit length. But I have to cube it. Come on. What is 4 cube? 4 4s are 16. 16 4s are 64. 128 divided by 64 is 2. 2 into 20 is 40. So it will be 40 unit mass per unit length cube, which is basically the new units. 40 new units. 40 in the new units. So where is it? Option number A. That's it. That's how you solve the question. Is this clear? Is this clear? Shirish, you will learn which are the dimensionless quantities as you progress in time in physics, like coefficient of friction, refractive index, strain, relative density. All these are dimensionless quantities. Okay? And any numbers like 2, pi, e, log, all these are like dimensionless. Sine, cos, tan, these are like dimensionless. Okay? These are all dimensionless. Yeah. Logarithms, sine, trigonometric functions, they are all dimensionless. Cool. Understood the second application. So what were the two things that we learned in dimensions till now? We learned that you can basically verify the correctness of any physical quantity. We saw how you can get the dimensions of anything and match it and find it out. Also, we saw that you can convert from one unit to the other unit very easily. Now comes the third part. Yeah, we'll take a break after this. We'll take a break after this third part, and then we'll directly go to significant figures, rounding off, and all those things. Okay, don't worry. All right, derive a relationship. Now, this is the most asked type of question. So pay attention, and then we'll take a break very quickly. Observe. See, in physics, if I tell you, the speed depends on the time, the distance, the force, and all of that, then you will think that, okay, maybe using some laws, I will get a formula for, okay, speed is force into time divided by mass into acceleration, something. But for that, you need to apply physics, right? You need to apply some laws, some principles, some theorems, etc. But without theorems, without physics, can you get a formula? The answer is yes, because of dimensions. Just because of dimensions, you can derive a relation between physical quantities in some cases, not every time. So that method I will teach you. The method is as follows. You should know the physical quantity depends on which other physical quantities. Other physical quantities. Also, if there is a constant, if there is a constant, is it dimensionless or having some dimensions, or having some dimensions? This is another thing which you should know. Also, you cannot use this method. Don't use this method if, number one, there is some addition or subtraction in the formula. Second, if there is logarithm or there is some trigonometric function or e raised to something exponents, then also you cannot use it. What do I mean by this? For example, S is equal to ut plus half at square. I cannot use this method. Whatever I will teach you, to find the formula, because there is a plus sign. This plus sign is the problem. This plus sign is the problematic thing over here. Even as simple as v is u plus at also I cannot derive. V is u plus at also I cannot derive. Reason being this plus sign. I cannot do it. You will see later on there are some exponential functions, formulas which you will learn later. Like for example, or even trigonometric based, x is equal to a sine omega t. You cannot use it only because of this trigonometric function over here. Yeah, again you will learn something called as loudness is 10 log I divided by I naught. You cannot use it again because of this logarithmic function. So these are the places where you cannot use the method which I am going to teach you. But where you can use is also very interesting. Like for example, f is equal to g m1 m divided by r square. Use it because there is no plus minus trigonometry, log, exponents, nothing. I can definitely use this. Also, I can use it for, let's say, some other formula also, like. Like say for example, force is equal to 6 pi eta into v. Some formula it is there in viscosity. Here also I can use because everything is multiplied or divided. No issues at all. No issues at all. I can use it in both these cases. Now, what is different in these two is this part over here. Is the constant dimensionless or having dimensions? This is the constant of proportionality. Force is proportional to mass, proportional to another mass, inversely proportional to R. Do you see very clearly this G has some dimensions? Whereas the constant over here, 6 pi, it is completely dimensionless. So you should know that from before only, or else you cannot solve the problem. Or else you cannot solve the problem. If the constants are there, can we use it? Yes, you can use it, but you should know either the dimensions or you should know that it is dimensionless. Either you know it is dimensionless or you know what is the dimension. Only then you can use this method. Is this clear? Okay. Yes. Why can't you use it for these things? Because logarithm and trigonometry is because these are dimensionless entities. So it's very difficult to predict whether there will be a log or exponent. How do I know? Okay, so you cannot guess how many terms are there, how many logs, sine, cos are there. Okay, this method simply cannot predict that. Okay, so let's try and use it. Okay, for a question, I will show it to you, the procedure of this, and after that you will get a hang of it. Okay, let's try it out. Let's try it out. Everybody, let's try it out. Paka? Okay, let's try it out. Let's say for example, I just tell you, listen, The ball, if it is dropped from the top, by the time it reaches the ground, the time taken, the time taken to fall, the time taken to fall depends depends on, let's say, the mass, maybe the height, maybe the height, and maybe the acceleration due to gravity. These are the three things. Can you now find the formula using dimensional analysis for the time taken for the ball to fall? Let's try this out, everyone. Shall we? Okay. What is the first thing that you will do in any kind of question where you have to derive the formula is assume. Always start with this word assume. Assume the time taken is some dimensionless constant into mass raised to some number which I don't know, height raised to some number which I don't know, gravitational acceleration raised to some number which I don't know. I want to find x, y, and z. Something raised to x, something raised to y, something raised to z. I do not know what those things are. Just assume. Just assume. Okay. Now, any formula which you write with equal to, the dimensions on the left hand side and right hand side should match, yes or no? The dimension should match, right, on both the sides. So can I then say the dimensional formula for t, dimensional formula for c, it is dimensionless, is dimensional formula for m raised to x, dimensional formula for h raised to y, dimensional formula for g raised to z. Obviously, this has to be true. Left hand side and right hand side dimensions should match, undoubtedly. Okay. What is the dimension of time? T. Okay. But what about mass and other things? I don't think it is there. Mass raised to 0. Length is also raised to 0. Only time is there. Here, mass is there one time. Height. Okay. Height is basically your length dimensionally. So raised to y. And g, acceleration, meters per second square. So length raised to 1, t raised to minus 2, whole thing raised to z. Whole thing raised to z. So technically this is m raised to x. Length is there here also, length raised to y plus z. And time is there only once, so minus 2z. So on the left hand side also, same thing, m raised to 0, l raised to 0, t raised to 1. Understand? I wrote it because on this side there was no mass or length, so that's why m raised to 0, l raised to 0. Anything raised to 0 is 1. Why did I write it like this? So that I can compare the powers. If m is raised to 0 over here, m has to be raised to 0 on the right hand side, or else it will not match it dimensionally. Agree or disagree? Agree or disagree? So dimensionally it has to match. So if you check m over here and m over here, 100% 0 is equal to x. 100% x is nothing but 0. Next, let's check the next number, length, or maybe even the time. Time over here and the time over here. Check it out. T's power is 1. On the right hand side, it is minus 2z. So what is z, guys? It is negative half. Negative half. Everyone with me? Awesome. Last one over here. Length's power here and over here. L's power is 0. So on the right hand side also, the total power should be 0. But wait a minute, z is negative half and y is minus z. So it should be minus of minus half. So what is y? It is basically plus half. What is y? It is plus half. Perfect. So I found the unknowns x, y, and z. So I will substitute it back over here. I will just substitute it back over here. Just see what will I get. T is equal to constant into mass raised to x. X is 0. So m raised to 0. Then you have length raised to, or sorry, it was height, my bad. Height raised to, what is height raised to? Height is raised to half, which is y. It is basically y. So it is basically half. And acceleration due to gravity, g is raised to z, which is basically minus half. Anything raised to 0 is basically 1. This is root of h. This is 1 by root of g. So actually it will be c root h by g. That is your time. So it is c root h by g. As simple as that. You can't find out the constant unless you do it experimentally. So if you're wondering, sir, what to do with this c, this has to be found, has to be found via experiments or via laws of physics, via laws of physics. But you leave the answer over here. Okay, that's it. Your options will be also in this form only. Answers will be also in this form only. Okay, understood. So mass is not coming only. Shirish, mass is not there only in the answer. If some option contains mass, you will first of all cross it out, eliminate it out. Mass just came out to be independent. Okay, this is how you solve the questions. Let's try out one more question, guys. Let's try out one more question. Everybody with me? Light up the chat box. I know you guys want a break. Now, after this, you're going to get a break, but this is the last question before we, disperse for the break and then again return back for significant figures and errors part. All right. All right. Let's do this. Let's do this. Okay. Say, for example, the force depends on density, area, and velocity. Find the formula using dimensional analysis. Okay, let's start. What should be the first step? I'll give you the hint. Always the first step is, if you know what it depends on, assume. First thing is assume. So let's assume our force is some constant into density raised to x, area raised to y, and velocity raised to z. Now start substituting the dimensions of each of the following. Force, m raised to 1 mass. Acceleration is L raised to 1, t raised to minus 2. Constant is dimensionless. Density, m raised to 1, L raised to minus 3, mass per unit volume. Area, this is A is area. It is length square. Length into breadth is area. So length square raised to y. Velocity, length per unit time. The whole thing raised to z. I think let's club all the similar things together. It will be much easier. So mass raised to 1, L raised to 1, T raised to minus 2 is mass raised to x. Mass raised to x. Length raised to minus 3x plus 2y plus z. Minus 3x, 2y and z. Time is only there one time, so raised to minus z. That's the most condensed form that you can think of. Now let's try and solve it just like before. I think mass is very easy to analyze. Left hand side RHS, the dimension should match for every single thing. So 1 will be x, or rather x will be 1. The next dimension that will be matching, I think, is of time. It's better. You can see it's very easy to calculate it. So minus 2 over here and minus z over there. Therefore, z is equal to 2. That is also done. Last one, length. Length. Oh my God, such a big thing. Length's power is 1. Here it is minus 3x plus 2y plus z. Wait a minute. X value is 1. So it is minus 3 into 1. Y value, I don't know. A Z value is 2. Okay, just put it over here. Minus 3 plus 2, minus 1. Bring that minus 1 over here. It will become 1 plus 1 is equal to 2y. Or 2y is 2. Or y is basically 1. So perfect. I got y, x and z. All the three things. So therefore, substituting it back over here, what should I get? Force is equal to constant into density raised to x. X is basically 1. area raised to y, which is area raised to 1, velocity raised to z, which is basically 2. Therefore, force is some constant into rho a v square. That is the answer. Rho a into v square into some constant 112. Got it, everyone? This is how you derive any formula. Did you get some confidence? Did you get some confidence, my dear warriors, now? Yep. So what and all have we learned till now? What is unit? What is dimension? The uses of dimensions, three uses: converting, checking if LHS is RHS, consistency. Third thing is deriving a formula. Seven fundamental quantities, two supplementary quantities. Supplementary quantities are dimensionless, everything else has dimensions. Derived quantities are dependent on fundamental quantities. Multiple systems are there. You should know how to go from one system to the other if you know dimensions. If you know formula, you can find out the dimensions very easily. That's all we have done till now. Let's take a quick break and we will return. Let's take a quick break and we'll return for significant figures. Okay. So I'll just put a timer maybe over here. 20 minutes break, guys. Okay. Meanwhile, smash the like button. Okay. In case you have forgotten to do that. The break time is over, my dear lions. Welcome back, welcome back, welcome back. I hope you guys are all done with your dinner. Hopefully, at least I am done. And if you're not done, I mean, you can still watch the lecture while having your dinner and just wind it up in the next couple of minutes. Quickly, get everybody on the channel. Yes, let's begin. Let's begin with the lecture, my dear lions. Welcome, 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 welcome back. So, before the break, we have seen what units are, what are physical quantities, and how they are classified into, derived and fundamental quantities. Seven fundamental and two extra supplementary units. Those units do not have dimensions, other things have their basic dimensions. And we saw how to find the dimensions and how to put it to use in three different ways. Uh, one was to convert units, one was to check the consistency of LHS, RHS. The last one was to derive the formula. Now let's go to errors part. That is the last part of this chapter. Let's roar all the warrior pandus whistle podoing. Let's begin with the class. Where is my pen? Yeah, it is right over here. Now, to go to errors, we need to learn this small thing which is called as significant figures. Significant figures and rounding off. If you understand it, then those error questions also become much easier. Significant figures means basically your digits of importance. Your digits of importance. Digits of basically importance. Like when I say when I say 007 Bond, James Bond, right? 007. Those zeros are insignificant. I mean, why do you even bother writing it? This and this is completely insignificant. Only this is a digit of importance. So the number of significant figures is just one. It has one significant digit. That's how we say it. So, my dear warriors, my dear lions, there are simple rules for predicting how many significant figures are there. And the rules, I have put it up over here. Okay. Now, these rules look like crazy, right? But let me explain this to you via simple examples. Okay. Let's have a look. Whenever any number is given and you want to find how many significant figures are there, use these rules. Do not by heart, understand it. Understand it, you will not by heart, because if you by heart, you will like, what is the 4 point? What is no, don't do that. Understand it, you will get it. All the non-zeros are significant. Kind of makes sense. And any two non-zeros are there, and between that, if there are zeros, those also become significant. So let's take an example. 198745. All these are non-zero digits. 1, 2, 3, 4, 5, 6. 6 non-zero digits. That's why it has 6 significant figures or 6 significant digits. Similarly, if there are zeros, but that zero is between two significant numbers, like 1 and 8 are significant, they are important digits, that zero also becomes automatically important. Even these two zeros, whether decimal is there, not there, does not matter. Between 8 and 9, we have two zeros. So 1, 2, 3, 4, 5, 6, 7. It has 7 significant digits. So all the zeros between two significant digits automatically become significant. Simple rule. That is the second rule. So you can probably make more examples like this. If I have 707, this important. So it has 3 significant figures. 5000607. 1, 2, 3, 4, 5, 6. This has 6 significant digits. As simple as that. Whether decimal is there or not there does not matter. 2, 0.04. 1, 2, 3, 4. That's it. 4 significant figures. That's how you count the number of significant figures. Moving on to the next one. All the zeros that are on the right of a decimal point and also to the left of the non-zero digit. This is the decimal point, to the right of it and to the left of the non-zero digit. Left of the non-zero digit. They are never ever significant, so don't even bother counting them. Don't bother counting them. So all these zeros are not significant. So 7, 9 and 8 only are there as significant digits, that is basically 3. To take an example, 0.02. This 0 is not of any importance. It's on the left of this 2 and to the right of this decimal. All these zeros become insignificant. Only one significant digit. What about this? 0.005006. These zeros become insignificant because they are to the left of this non-zero and after the decimal. So guys, forget all these things. 5 and 6 are significant, and these two zeros, they become significant because they are between two non-zeros. So this has four significant figures. This has four significant figures. Understood, guys? Everyone? All the lions? Yep. Yep. Okay. Moving on to the next one coming up on your screen. Okay, this is also done. Now the next rule, all the zeros on the right of a decimal are only significant. So when you are going after the decimal, they become significant only if, only if a non-zero digit does not follow them. Only if a non-zero digit basically does not follow them. All right. So, you will see that all these decimals, there is a 0 like this, there is a non-zero number after it, no. So all these zeros automatically become significant. Basically, so if I say 5.0, this 0 is not followed by any non-zero. It's basically after the decimal. There is nothing after it. Automatically, it becomes significant. When there is nothing after it, automatically it becomes significant, assuming it is after the decimal. Assuming it is after the decimal. Same way, this is having two significant figures. Same way, if I write 2020.000, first of all, this 2 is significant, this 2 is significant. This 0 is between two non-zeros, significant. These zeros are after the decimal and nothing is there after it. Automatically, they become significant, and so does this 0 because it is again between two significant numbers. 1, 2, 3, 4, 5, 6, 7. So this has 7 significant figures. Understood, my dear warriors? Yep. Understood, my dear lions? Very, very straightforward. Let's take more examples. 500.0. This 0 is after the decimal, nothing after it, definitely significant. This is also significant. Any zeros between two significants are also significant. So this has four significant figures. That is your next rule, okay, which has been mentioned over here. Now, all the zeros that are on the right of the last non-zero and after the decimal point are also significant. I think this also we indirectly did it. Okay, so imagine this, something like this, 0.0200. The moment these zeros are after the decimal, they automatically should be considered as significant. But these zeros are not significant. I have told this to you before also. These zeros on the left-hand side are not significant. So this has three significant figures. This has three significant figures. Take more examples. If I take 0.007070, this and this and this are not significant because they are on the left side of the first non-zero number. 7 and 7 are significant. This 0 is in between them, and this 0 is after the decimal. It has to be significant. 1, 2, 3, 4. This has four significant figures. This has four significant figures. That is there without the decimal, is there without the decimal, then it is basically not significant. All the zeros that are on the right of the last non-zero digit are significant if they come from a measurement. For example, 1090. Okay, that rule is completely different. But if there is meter written in front of it, then this 0 becomes significant. If there is no meter word here, there is no decimal in between, then this 0 becomes insignificant. So let me show this to you with an example. If I write 20 meters, this 2 and this 0 both are significant. So this has two significant figures. But if I just write down number 20 with units, only this is significant, this is not significant. In fact, this is as good as saying 2 into 10 to the power 1. In fact, powers of 10 are also not significant. So this has only one significant figure. This has only one significant figure. To give you more examples, if I write 50500, all right, without any units, this, and this are significant, these two are not. This is as good as saying 505 into 10 to the power 2. Ignore this. This has only three significant figures. Only three significant figures. But if I write 50500 kg, then 1, 2, 3, 4, 5. This has five significant figures because there is a unit mentioned. So whenever there is a unit mentioned, whenever there is a unit mentioned, basically it's a part of a measurement, then it will be considered as significant. Understood, my dear warriors, my dear lions? Is this absolutely clear? What are the rules of significant figures? Shall we now do some questions based out of this? Shall we now do some questions based out of this? Come on, I want everybody to answer this. How many significant figures are there in 70070? How many significant figures are there in 0.0707? How many significant figures are there in 0.07700? How many significant figures are there in 7.07? How many significant figures are there in 70.00? How many significant figures are there in 70 into 10 to the power minus 5? Okay, come on. Try to solve these questions, my dear students, my dear lions. Figure these answers out. Figure these answers out quickly. All these answers out. I will write more examples also for all of you. Okay, come on. First answer, very, very straightforward. 7 and 7 significant, 0 in between them. This 0 without any units, not significant. So it has four significant figures. Four significant figures for the first one. Very nice. This 7 and this 7 are significant. This 0 is in between them. Perfectly fine. This 0 is to the left side of the first non-zero number, not significant. Anything before that also not important. So this has three significant figures. Very good. Many of you are getting it right. Now, this 7 and this 7 are significant. And what about these two zeros? They are after the decimal point, so they are significant, but the left-hand side ones are not significant. So this has four significant figures. This has four significant figures. Very good. Many of you are getting it right. This 7, and this 0. All three are significant. The 0 is in between the 7s. Whenever you have a decimal and then two zeros, they have to be counted as significant figures. Keep that in mind. So 7000, perfect. All of them have four significant figures. Perfect. Okay. Any zero after the decimal, okay, and there is nothing following it, it is to be counted. The powers of 10 are never counted. This 0 is also not counted because there is no unit mentioned. Only one number is there, so it has one significant digit. Exactly one significant digit. They will come live after some time on the NEET English channel. Let me complete this video, or else it will be like half-hearted lecture then. Okay. How about this? 0.7708 into 10 to the power minus 5. 0.08080 0.050020 into 10 to the power 3. 7 point, okay, and then 7080 meters. Okay, come on, let's figure this out. What are the significant figures in each one of them? Let's start with the first one. 778, and this 0 is in between. Powers of 10 never significant. Any 0 before the decimals not to be counted as significant. So I think this has four significant figures. How many of you wrote four? Very good. Proud of all of you. Any zeros before are never counted. This 8 and this 8 counted. 0 is in between, so definitely count. The last 0 is not followed with a measurement value, so it is not significant. So I think it has only 3 significant figures. Proud of you. Some of you said 4. Guys, be careful. There is no decimal here. Number 2, it's not measured as meters, kilometers, nothing. So do not count the last 0. Be careful. It is not to be counted. Yeah. Okay, you guys made a mistake. Most of you made a mistake. 5 obviously is significant. 2 is significant. Powers of 10 never significant. These two zeros are in between, so counted. Zeros to the left of the first non-zero, never ever counted. Okay, this 0 is after the decimal, so you should count it. 1, 2, 3, 4, 5. So 5 significant figures. Just check this out. 5 significant figures. Exactly. Next one. What about this? What about this, my dear warriors? When I put 7 dot, how many significant figures are there? It is basically one significant figure. Yes, it is only one significant figure. When there is a decimal and there is no 0, that's it. It is one significant figure. If I put 7.0, 7.0, then it has two significant figures. This has two significant figures. Okay, got it? Perfect. So with just a decimal, one significant figure. Okay, not to be counted. That 0 is not there. Okay, what about this? This, and this counted. There is some unit. This is a part of a measurement. So this becomes significant. So this has 4 significant figures. Perfecto. Perfecto. Awesome. Now you are fully confident, my dear warriors, my dear lions, how to count the significant figures. Now, let me tell you, you can also combine them. And before you combine them, you should also know how to round them off. It is not that difficult. See, this is also going to be important, particularly for all of you. So you should know the rules of rounding off. Rounding off, very, very straightforward. If I have 27.3 and I want to round it off to two significant figures, I want to get rid of the decimal, or let's say it is 2.73. I want to round it off to two significant figures. So when I round off, what you should always do is always check the last digit. Always check the last digit and see whether it is more than 5 or less than 5 or equal to 5. This number 3 is obviously less than the number 5. If it is less than number 5, the previous digit, write it down as it is. Do not change anything over there. So this will be just basically 2.7. That's it. Don't do anything to it. It will just be 2.7. Next, let's say, for example, it so happens, the number that you are rounding off is 2.78. Now you want to round it off to one decimal, or basically two significant figures. Always check the last digit. Always check the last digit. Okay, the last digit, it is more than 5. The moment it is more than 5, the previous digit, add 1 to it. Add 1 to it and write it down. So my dear warriors, lions, what will it be? It will be 2 point, instead of 7, it will be basically 8. 7 plus 1 is 8. Understood? Yes, 78 is closer to 80, obviously, and 73 is closer to 70. That 0 is missing, but visualize it. Simple. But what if it is 2.75? Now check the last digit. The last digit happens to be equal to 5. Then check the previous number. The previous number is odd. Because the previous digit is odd, you will add 1 to it and then write it down. So the final answer will be 2.8. 2.8 if it is equal to 5. And let's say by chance, if it was 2.45, and now you check the last digit, it is also equal to 5, but the previous digit, if it is even, then you don't do anything to it. You keep it as even. Always even is favored as compared to odd. Odd is odd. So you ignore it. You always try to keep even. So 4 remains as 4. So it will be 2.4. So whenever it is ending with 5, you have two options on both sides. So the one which is even will be the correct one. The one which is going to make it even will be the correct one. Got it? As simple as that. Let's see if you guys can solve this particular question. 2 point, or let's say 26.475. Write it down to two decimal places. Sorry, not two decimal places, one decimal place. Round it off to one decimal place. So now you have to get rid of 7 also and 5 also. What will you do? Which digits will you check? Always, guys, see, understand the logic. Here, I wanted to get rid of one digit. So I checked the last digit and compared it with 5. Less than 5, more than 5, equal to 5. Here, I want to get rid of two digits because I want only one decimal place. So if I want to get rid of two digits, if I want to get rid of 7 also and 5 also, you have to not check the last digit, but the last two digits which has to be eliminated. But this number, don't compare it with 5. You will now compare it with 50. Is this more than 50, less than 50, or equal to 50? 100% it is more than 50. If it is more, then the previous number, what will you do? You add 1 to it. Just like if it was more, the previous digit, you add 1 to it. That's it. You write it down. Your answer will be 26.5. That is the answer. 26.5. Got it? Simple, easy peasy. Let's try out one more number. Okay, let's take something else like 900 and or 98.2500. I want to convert it into only one decimal place, only single decimal place, meaning I want to get rid of this as well as this. Three things I want to get rid of. Three things I want to get rid of. So now you will check the last three digits, but this time don't compare it with 5, not even 50. In fact, with 500. Oh, wait a minute. It is exactly equal to 500. It's exactly equal to 500. So what will you do? Check the previous digit. 2. Wait a minute. It is even. So you don't even have to do anything. You don't even have to do anything. If it is equal and the previous one is even, as it is. If it is odd, add 1 to it. So my dear warriors, it will be just 98.2. 98.2. Isn't it simple? Understood the logic behind the rounding off? Everyone, rules are clear. How to apply the rounding off? Very good. Now that you know how to round off numbers, sometimes you might need it. So let's come back to significant figures and let's see how do we add and subtract numbers. Very simple things, but I think yeah, let's do it over here. How do we add and subtract? The first thing is addition and subtraction. This is the first thing that we'll learn. The second thing that we'll learn is basically multiplication and division. That is what we're going to learn. So addition, subtraction separate, multiplication, division separate. So let me tell you how this works. Very simple rules. If I have the number 20.000 plus 5.0 versus, let's say, 7.00 minus 2.000. Okay, let's try out this addition and subtraction. In case of addition or subtraction, what you need to do is always the final answer will have as many decimal places as the least of the decimal places. The final answer will have the least of decimal places. Least of the decimal places. Yes. Let me explain. Check this out. 20 plus 5 numerically the answer should be 25. Forget about the decimals. 7 minus 2 numerically the answer should be 5. Forget the decimals for now. Now use this rule. Least of the decimal place. Do you see over here Over here, there is one decimal place, here 1, 2, 3. So this is having the least decimal place. Hence, the answer will be 25.0. 25.0, only one decimal place. Very good. Here, if you notice, there are two decimal and here there are three decimals. So this is the least decimal place. Hence, our final answer will also have two decimal places. As simple as that. Got it? So easy peasy lemon squeezy. Sir, but in before question you change it to 26.5. Why you won't just keep it as 26.4? Which one? This one? Because in the previous question, this 75 was more than 50. If it is more than, what do you do? If it is more than, what do you do? The previous one, you add one to it because 78 is closer to 80, right? Same way, think 475 is closer to 500. 475 is closer to 500. So that's why I will write it as 0.5. That's why I add one to it. Cool? Easy? All right. What about multiplication and division? Let's try that also. It's very straightforward, my dear students. I mean, look at this. If it is 7, all right, 7.00 multiplied by 2.0, okay, 0, or let's say 0.02, okay, 0.02. Now, if I want to multiply them, and then again, let's take some another number like 40.00 divided by 5.0. Okay, let's try this out. Whenever you have multiplication and division, then the rule is very similar but slightly different. It's not least of the decimal place, it's actually least of the significant figures. Least of the significant figures. Let's try this out. 7.00 and 0.02. If you normally multiply, what should you get the answer as value wise? Let's write a rough estimate. 7 twos are 14. 7 twos are 14. And this is 0.02. So there will be a decimal place here. We just keep it on the rough side. 40 divided by 5 numerically should be 8. Decimal places, I will figure it out. Now let's check the significant figures. 700 decimal is there, so 3 significant. 0.02, this is not significant, this is also not significant, so only 2 is significant, so 1 significant figure. Exactly, 1 significant figure is there. Everyone understanding this? Here 1, 2, 3, 4, so 4 significant figures. This and this 2 significant figures. Who is the least? This one is the least. This is basically the least in this case. In this case, this is the least. So the final answer should also have the least significant figures. 8 is one significant figure. We need one more. So why not write it as 8.0? Now this has two significant figures, which is the least of them. Hence the correct answer for this question is 8.0, not because of the decimal, because of the significant figure. Got it? Okay. The weightage of the chapter, pakka guarantee one question, most likely two questions. So 4 marks to 8 marks. Out of 25 questions, I mean, 2 questions is a big deal only, no? Okay. How about this? I want one significant figure. How do I write 0.14 as one significant figure, guys? Think about it. 0.14 is nothing but 1.4 into 10 to the power minus 1. Oh, this is not significant, but this has two significant figures. I have no other option but to round it off. I have to round it off, guys. No other option is there with me. So check this number. Check this number. Definitely it is less than 5. So the previous, or you can even do this. If you don't like it like this, you can also write it as 14 into 10 to the power minus 2. So now check this number 4. This is less than 5. So the previous one comes down as it is. So, my dear warriors, what will happen? It will be 1. Okay, it will be just 1. And if I put a 0, no harm in that, into 10 to the power minus 2. That's the rounded off. That's the rounded off value. 14 is close to 10. Round off 14 to the nearest multiples of 10. It is basically 10. So 10 into 10 to the power minus 2 is the answer. Remember, this 0 is not significant. This is not significant. This is significant. So this has one significant figure. So the answer of 7 into 0.02 is not 0.14. It is 10 into 10 to the power minus 2. Isn't it crazy? Isn't it crazy, guys? Yeah. What a miraculous problem. And this is the problem where many students will make a mistake in. Okay, because they will think the answer should be 0.14, but the answer will be something else only. The answer will be something else. Okay, so 10 into 10 to the power minus 2, you can also write it as 1. That's also fine. 0.1 is also fine. Yeah. Yes, Dikshita, I'll continue these classes daily only if you show interest. If you don't show interest, then I will be like, okay, you guys are only not interested. So it's your responsibility, morally, ethically, everything, that you have to make this channel popular, this series popular. Invite your friends, recommend this, share, like, subscribe, put it on the status. We grow as a community and it helps everyone, right? Yeah, the DPPs will be provided very soon. Don't worry. After the class is over, just give me some time. It will be posted. All right. So let's find out the answers with the correct significant figures. Everybody try this out. 98.9 plus point 0.10. Come on, try this out. Try out the answer. Next, 2.50 multiplied by 0.005. How much is this? Try this out. Yes. 1.11 minus 1.110. No. 0 and then 000. Yes. What is the answer for this? 3 questions in front of you. Come on. Yes, I know you guys will be regular and you want the syllabus to be completed soon. In fact, let me tell you, I want as many lectures as possible, at least 80% syllabus to be done by August or July. Let's target it. Let's try to cover up as many classes, as many lectures, as much syllabus as possible by July, August, let's target it. I mean, targeting is a good thing. I'm not saying I will do it. If I do it, very good. So always set very high targets, but achievable targets. So 100% of the syllabus, if we can do it by September, that will be the best thing. I mean, you will get September and October, November, December for revision. So we can have October, November, December, 3 months at least, bare minimum for revision. Okay, so let's try this out, my dear warriors, my dear lions. Okay, so let's try this out. Normally, if I do it without thinking about the rules, this will just become this, forget this 0. 9 plus 1 is 10. So 1 carries over. So 9 and then 9 over here. Okay, then this decimal, we'll think about it. 2.5 into 0.005. Okay, so this is as good as saying 2.5 multiplied by 5 into 10 to the power minus 3, which is as good as saying 7.5 into 10 to the power minus 3. Just leave it as it is. I have not yet attached the proper significant figures. So this one cancels, this one will also cancel. So I think it should become 10.0. I don't know whether decimals are matching or not. The answer is 10. Okay, now comes the thing about decimals and all those things. Here always check the decimals. 1, 1, 2. So this is the least decimal. Here 1, 2, 3, 1, 2, 3, 4, 5. So 3 decimals. So this is the least of the decimal. Addition subtraction means decimal places. So let's write down the final answer. So I should have one decimal place only. So I think the answer should be 99.0. Yes, that is the correct answer. Perfect. Here I should have three decimal places. Okay, so 10.000. Yep, three decimal places. Perfect. Perfect. Here, check this out. We need to check the significant figures. One, two, three. So three significant. Here only one. So final answer should also have one significant figure. 7.5. What will I round it off? 8 or 7? 8 will make it even. So yep, the answer should be 8 into 10 to the power minus 3 because that has one significant figure. 7.5 has two significant figures, 7 and 5. 8 has one significant figure. Why did I not write it as 7? Because 7 is an odd number, right? So 7 is an odd number. I will add 1 to it to make it even. Cool? Understood? Oh? Clear, oh, my lions? Everyone? Very nice. Very nice. Oh, why did I write 25 into 5? Array, what am I doing, guys? I thought 25 into 3. Sometimes it happens. Brain fused. Sorry, guys. Why did I write it as like this? I mentally thought 25 threes are 75. It is 25 fives are. What is wrong with me? Happens sometimes. Yeah. So it should be 12.5. It is 125. Yeah. So 10 to the power minus 3. But still, I have to convert it into one decimal place. So to convert it into, sorry, one significant figure, 12.5, one significant figure, that's 10 into 10 to the power minus 3. Perfect. So this is basically 10 to the power minus 2. 1 into 10 to the power minus 2. That is the answer. 1 into 10 to the power minus 2 is the answer. You will round it off because 12.5, no. It has three significant figures. I want one significant figure. So 1 into 10 to the power minus 2. That's it. Oh, yo, don't put 13. 13 has two significant figures, Tejesh. 13 has two significant figures. Be careful. Yeah. Don't put 12.5 as 13. Why? 13 is 1 and 3. Two figures. So what is the nearest number to 12.5? 10. 10 is the closest multiple of 10 to 12.5. Got it? Not 20. Is that understood? Clear? Everyone? These confusions happen very, very often in these significant figure questions. Let's go to the next level 2. Level 2 question. This is level 2 question. Let's see if you guys can solve this. I feel very easily you will be able to solve it. The edge of a cube is 7.203. What is the volume with correct significant figures? Yes, Siva. Even on school days, we'll be taking the class at 5 o'clock only. The reason being, you can see my lectures go on for a long time. So I want to be done at a decent time so you get time in the night for self-study. Okay. So my dear warriors, my dear lions, this is 7.203 multiplied by 7.203 multiplied by 7.203 is the volume. And when you multiply, you always count the significant figures 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So all of them have 4. So the least is also 4. So the final answer, whatever it is, should have 1, 2, 3, 4 significant digits only. You don't even have to sit and multiply. Just check this. This has 4. This has 1, 2, 3, 4, 5, 6. This has 1, 2, 3, 4, 5. This has 3. You don't even have to solve it. The answer must be 373.7. That's it. Let's check it out. Yes, answer is C. Understood how to solve this level 2 question? You don't even have to do the multiplication. A lot of people are going to waste a lot of time multiplying it. You don't have to actually. You don't have to. Correct. Very nice. Let's move now to the last part. Supriya, did I ask anything wrong? What did you ask? Where is your question? I can't see your question. Okay. Errors part. Let me tell you. There is nothing in this world which is error free. The biggest lie told to you as kids was if you measure something, that is perfect. In school, tell me one thing. When you are asked to, when you are in second or third, and you learn to use the scale, the protractor, right, the compass and all these things for the first time, and you buy the geometrical box for the first time, probably one of the uh, most exciting times of your life. Something new has come into your life. This is a new compass geometrical box. Usually you carry your pencil box. So you measure the length of some object over here, and then you use your regular scale, and then you place your zero over here, markings. Let's say this is 7 and this is 0, and then you're like, oh sir, the answer is the length is 7 millimeters. But let me tell you, no matter what you do, you will have some error in that 7 also, because if you zoom onto it, these scales have markings on it, so there is a room for error. There is a room for error. Exactly, there is a room for error in the measurement. Correct? So you will see, whatever measurement you do, whatever measurement you do, so any measurement has a scope of error in it. So any measured value, any measured value is going to always look something like this. Most probable value plus or minus, plus or minus the uncertainty in the measurement, sometimes also called as the absolute error in the reading. So, for example, if I measure the length using a scale, maybe the length could be 7 millimeters plus or minus 1 millimeter, meaning there is a range of values. There is a range of values starting from 6 millimeters to 8 millimeters. The answer will be somewhere in between of this. I don't know actual value if it is 6.5, 6.8, 7.2, 7, 7.99, 6.01. I don't know. It could be anywhere between this. There is a scope of some uncertainty. Yep. Is this clear? What is the meaning of error and why it comes? Now, this error can come because of many reasons. One of the reason is the instrument. One of the reason is basically the instrument. Another reason could be it is completely random. It is completely random. Suddenly the wind started blowing, something fell on it, so it bent, so the instrument got spoiled, and that is why you got an error. Sometimes the errors are basically, completely human in nature. Human in nature. One person at some time he will get some other value, other person the way in which they are conducting. So, it could give you a completely different value. Basically, the human conducting it or the experiment being conducted is different. So there are many reasons why you might get different values, and there is a scope of uncertainty. You can never be sure what the actual value is. If somebody tomorrow, as an engineer, you get asked, what is the actual length, you will never ever be able to tell it. No matter how accurate your device is, it will always have a room for error. Is this entering your head? Is this entering your head? TLT, I'm very good. I'm very good. Okay. Yeah, Avanishri, this is the last part of the class. Yep. Order of the magnitude, that kilo, omega, giga I have taught at the beginning. Just take the starting part of the class. Everyone, till this point it is clear? Okay. Now, just imagine this. Just imagine this. One Pandu is there. One Pandu is there, and he measures the length of something to be, you know, 10 meters plus or minus 1 meter. Champa is measuring something else, and she measures the length of that object to be 100 meters plus or minus 1 meter. Who do you think has more uncertainty? Who do you think has more absolute error? Who do you think has more absolute error? Or Champa? Uncertainty or absolute error, right? Is this part after the plus or minus? This is the one over here. Who has more uncertainty or absolute error? My name is Captain Shreyas. Thank you for having crush on me. I hope that crush translates into marks. If that happens, I will be more happy. Okay. 1 and 1, both are same. Oh my God. So definitely, both have the same uncertainty or same absolute error. Both have the same absolute error. Agree with this? No, not Pandu, not Champa. Both of them have the same absolute error. Think about it. I mean, for Pandu, in 10 meters, the uncertainty is this much, 1 meter. But for Champa, in 100 meters, the uncertainty is still the same. If you look at it relatively, if you look at it relatively, who has more error or who has less error? Think about it. Come on, guys. For Pandu in 10, the uncertainty is only 1. For Champa, in 100, the uncertainty is 1. So I think Champa is more accurate as compared to Pandu. So in fact, we have a term called as relative error. Yes. So relative error for Champa, relative error for Champa will be error is 1 in 100, 100th. Whereas relative error for Pandu is 1 in 10, which is slightly higher. In fact, you can also write something called as the percentage error, where you take this number and multiply by 100, it becomes 10%. In this case, the percentage error will become 1 by 100 multiplied by 100, which is 1%. Kind of makes sense. For Champa, 1 is 1% of 100. Yeah, correct. Hardly any error. For Pandu, 1 is 10% of 10. Yeah, so this is more error. So Pandu has relatively higher, percentage error or relative error. So which one is more important? I feel it is the percentage or the relative error, which becomes more important while, analyzing who is more accurate, who is more precise. Yeah. Is that clear, everyone? Awesome. So let's define the terms. Let's define the terms. If you have any measurement which is given by A plus or minus delta A, any measurement, the absolute error is just given by delta A, which is also the uncertainty in the measurement. Uncertainty in the measurement. Relative error is how much is that uncertainty upon the original value. It's always a fraction, like over here, 1/10, 100, 0.5, 1/6, 1,000, like that. So it is a fraction. Whereas the percentage error is nothing but the relative error multiplied by 100. So it is nothing but delta A by A multiplied by 100. That's all. That is called as your percentage error. Is this point clear? Is this point clear? Yes. Awesome. So glad. So glad. Say, Asta, you are understanding everything. Perfect. Samad, NEET students can also watch it, but we have a NEET English channel, Vedantu NEET English. Watch it over there. I'll be starting the series very soon. Okay. Yep. Can you crack JEE? Why not? TLT, you can definitely crack JEE. Who said that you cannot crack JEE? I mean, why should that be even a question? First of all, I'm not able to understand. Okay, now sometimes you do not know the uncertainty. Sometimes you do not know the uncertainty so easily. In fact, you have to find that uncertainty. And for that, what happens is a student performs the experiments multiple times, or multiple students perform the same experiment. So, when multiple readings, when multiple readings are taken, then how to find the relative error, percentage error, etc. The logic is as follows. You take down the readings, reading 1, reading 2, like that, reading number n, reading number n. After that, what you do is find the average value of the readings. Find the average or the mean value. Average or mean is one and the same thing. So it is nothing but, you take all these numbers, R1 plus R2, like that, till Rn, and just divide it by n, the number of quantities, n number of quantities. Keep this aside. Now what you do is, at every single place, what you do is, for R1, find how different is R1 with R average, and just take the modulus of it. So do this, R1 minus R average, R2 minus R average or R mean. Do this for everything, Rn minus R average. Modulus, that means you are not worrying who is more, who is less, just taking the positive difference. This is called delta R1. This is called delta R2. Like that, last one will be called delta Rn. These are called as absolute errors. Absolute errors. How much is the deviation from the most probable value? You have some numbers, you find the average value. From the average, how much are you deviating? So you are taking the absolute deviations from the most probable value. What you do now is basically find the mean absolute error. Mean absolute error. When I say mean absolute error, it is basically the average of these things. So you take all these numbers and divide it by n. That's all. Basically, it is delta R1 plus delta R2, like that, delta Rn. So that will give you the mean absolute error. Hence, our final answer, will be something like this. It will be this most probable value, which is R average, and then you will have plus or minus, which is mean absolute error. Mean absolute error. This is how you will write down the final answer. Let's take an example and then let's understand it. Let's take an example to understand this, okay? When you have multiple readings. Here is the example. What are our readings? 12, 10, 9, 7. Readings 12, 10, 9, 7. So let's write it down. 12 is one number. These are your readings. These are your readings. Okay, 12, 10, 9, and 7. What is the first step? Take the average value. Take the average value or the mean value. So the readings average value will be nothing but, there are 4 readings. So divided by 4. What are the readings? 12 plus 10 plus 9 plus 7. How much is it coming out to be? How much is the average value coming out to be? Put it up in the chat box right away, right now, my dear warriors. Put it up right now, my dear warriors. How much is it coming out to be? Come on. Yes, 9 plus 7. Come on, do it. Yes, how much is it coming out to be? Everyone, put it up in the chat box. Quickly. Yep, Very good. Very good. Some of you have got it. Yes. Very nice. Finally. Very good. 9.5. Very good. Perfect. Because the final sum will be how much? It will be nothing but 30. 8, I believe. Yes. So it will be 19 divided by 2, which is 9.5. Perfect. Now comes the next step. Next step is what? You have to find the absolute errors. So the absolute error means you subtract 12 with 9.5. 12 with 9.5. Then 10 with 9.5. Then 9 with 9.5. Then 7 with 9.5. 7 with 9.5, but take the modulus everywhere. Everywhere. How much will this be? This will be 2.5. Correct? This will be zero point 0.5. This will be also zero point 0.5. This will be nothing but 7. Yeah, correct. This will be 2.5. Perfect. Check this out. Everybody with me? What is the next step going to be? You are going to take the average of these. So the mean absolute error, the mean absolute error, this whole thing divided by 4, this whole thing divided by 4, 2.5 plus 0.5 plus 0.5 plus 2.5. Come on, my dear warriors, how much is it? Quickly. Yep, yep, yes. 2.5 plus 0.5 is 3. 3 plus 3 is 6. 6 divided by 4 is 1.5. Very good. Perfect. So see if you got the answer as your 1.5. So, my dear warriors, my dear lions, what will be our final answer going to be? What is our final answer going to be? It is going to be 9.5. 9.5 plus or minus 1.5. Plus or minus 1.5. Got it? That's the answer. That's our final most likely answer. It will be most likely 9.5. Plus or minus chances are there somewhere between, plus 1.5 minus 1.5 from 9.5. If you talk about the percentage error, if you talk about the percentage error, it is the error which is there, which is 1.5 upon the most probable value, which is 9.5, the whole thing multiplied by 100. Come on, my dear warriors, my dear lions, what is the answer going to be? 15 and 95. We can divide by 5 each. So this will be 3 times, this will be 19 times into 100. So approximately how much is that percentage error going to be? Come on. 19 ones and 19. So you have 11, then 0, 5. So approximately 15 point something. Just check this out. 15.7 or something. 15.7%. Just check this out. 15.7. Yes, perfect. That would be the percentage error. Understood how to solve these problems? How to find the absolute errors, how to find the final answer, and then finally calculating the relative and the percentage error. Very, very simple, right? So we have learned what the basic errors are. What the basic errors are, how to do the calculation of it. Okay. Now, do you know that basically you can also add and subtract? You can also multiply and, divide with errors. You can play around with errors. That is the last subtopic of how to handle the combination of errors. What do I mean by this? Let's understand. Let's understand. Say, for example, I have the number, let's say, uh, 8 plus minus zero point 0.2 plus, if I have to add, 3 plus minus 0.4. Okay, I want to add this. Second problem, 7 plus minus 0.5, 2 plus minus 0.2, but I have to subtract them. Basically, I have two readings and I want to combine them together, either by addition or by subtraction. Subtraction is also combination. I am combining 7 and 2 together. They both have some uncertainty. So what is the final uncertainty in them? Interesting result. Whenever you have addition and subtraction, always remember, do the normal math for the main values. Main values. These absolute errors which are there, absolute errors are there. You always add them. Always add absolute errors. Always add absolute errors. The other thing, just do the normal maths. Meaning, for example, over here, 8 plus 3 is basically 11, put plus or minus. 7 minus 2 is 5, put plus or minus. Only for this error part, you just follow this rule. Always add 0.2 and 0.4 will make it 0.6. 0.5 plus 0.2 will make it 0.7. Lot of students do this, they subtract this also. That is wrong. 0.5 minus 0.2 is wrong. 0.5 plus 0.2 is correct. That is the catch. Yeah, always, always. Vishal, that is a separate whole entity altogether, screw gauge and micrometer and all that. Experimental physics, we'll do it sometime later as a special class. In fact, I have done a special class on it on the channel itself. All the instruments together, all the experiments together, first time on YouTube. Okay, it's done. You can check that lecture out if you want to. But that is not so important right now. Generally, experimental physics is done towards the end of the syllabus. Okay, don't worry about it now. All right. So if this is clear, find the error in the following combinations. Let's see if you guys can figure this out. 20.0 plus minus 0.5, 7.0 plus minus 0, 0.1, sorry, 0.01. What do you think the final answer should be? What do you think the final answer should be? Come on, do this. Okay, do this. Then you have 0.0 plus minus 0.1 minus 20.0 plus minus 0.3. You have to subtract this. Come on, my dear warriors, my dear lions. What is the answer for this? Come on, think about it. Yeah. Tamil, just a couple of more minutes and we are done. Just do the normal maths first. 20 and 7 is 27. 60 minus 20 normally is 40. Now go step by step. Whenever the absolute errors are there, what will you do? You will always add whether it is addition or subtraction. So 0.5 plus 0.01 is 0.51. Here 0.1 plus 0.3 is basically 0.4. But there are some catches involved over here and I'll tell you what it is. The decimals. The decimals. Whenever you add and subtract, what should you do? You should be very careful about the decimals. The final answer should contain the least of the decimal places. This has 1, this has 2, this has 1, this has 2. So what should the final answer contain? 1 decimal place. So hence the answer will be 0.0. Answer will be 0.0. Here also there is a problem. This has 2 decimal places, this has 1 decimal place. I can't keep 2, I have to keep 1 decimal place. So my dear lions, what I'm going to do? Approximate it to 1 decimal place, which is 0.5. Single decimal place. Got it? That is the catch. And that's why our final answer to this question will be 27.0 plus minus 0.5. No 5.1. If 5.1 is there in the answer, you will cross it out. You will eliminate it. You will get negative marks otherwise. Cool? Here, I don't think we need to do much. I mean, it's pretty much obvious. Single decimal place, So single decimal place, single decimal, single decimal. So plus minus. Okay. This answer is as it is. 40.0.4 plus minus. Perfect. Nothing wrong here because both had one decimal place each. So that also matters. Yeah, this is the common mistake. These kind of questions have come in JEE. So this is a proper level 2 question, guys. This is a proper level 2 question. Moving on to the next one. Yeah, this is beautiful question. Actually, you will love this question. This is level 2 properly. I mean, the previous one, I won't even categorize it as level 2. This is level 1. Okay, just small trick. If percentage error in the measurement of the length of an object is 4%, if it is broken into halves, then the percentage error will be. If you answer this, I will be really proud of you. So basically, imagine there is an object. There is an object, okay, and it has some uncertainty in it. It has some, uncertainty in it. This has some uncertainty in it. This is that uncertainty. You break it into two equal halves. You break it into two equal halves. So what is that percentage error which will be there in each one of them? What will be that percentage error in each one of them? Come on, my dear Lions, if you get this, I will be really, really proud. For sure, I should book a seat for all of you in the IIT Bombay, Madras, Delhi campus. Hello, Mati. Let's see if you can figure this out. Okay, I'll tell you one simple thing. Just observe. Assume this is L1 plus minus delta L1. This will be also L1 plus minus delta L1 after breaking it into two parts. If I combine them together, L1 plus minus delta L1, L1 plus minus delta L1. If I add them, if this is L plus minus delta L, I should get L plus minus delta L. I should get back the original rod, the original object. So if I use that logic over here, think about it. I do not know what is L1. I do not know what is L1, but I know the final answer. Assume it is 100 units. Error is 4%. Error is 4%. So is it not like saying it is 100 plus minus 4? 100 plus minus 4. So think from this, what L1? Think about these both will add to give you 4. So delta L1 is 2. Correct? So what is the percentage error? What is the percentage error in each one of them? The absolute error upon the most probable value into 100. What is this? 0, 0 cancels. This goes with this. This is still going to be 4%. Yes, the answer is B. It is still going to be 4%. What a beautiful question. And I proved it to you logically. Very good, Tarun, Tejesh. Okay, don't spam. But yeah, you got it. I know you guys are very excited to mark the answer as B. Isn't it fascinating? Generally, what people think is, the error will get divided, it will become 2%. Actually, what becomes half? What becomes half? Absolute error. Did you see that? Absolute error became half. Yes, when I divided it, the absolute error got divided, but even the length got divided. So the ratio remained the same. 50 by 2, 100 by 4 is one and the same thing. That's the reason. Cool. Let's move on. That's why it's level 2 question. Let's move on. Last part, multiplication and division. Now I'll tell you what, multiplication, division, and in general for any powers and basically powers. The rules for them is same. The rules for them is same. I'll tell you why. Example, I write power is force into velocity, or let's say velocity is displacement divided by time, or let's say kinetic energy is half mv square, or let's say uh, time taken to fall is root of 2h by g. Multiplication, division, in general, any powers, this works. The rule is as follows. The rule is as follows. Always To find out the error in the final quantity, if each of them have some error, meaning force has some uncertainty, velocity also has some uncertainty, power will also have some uncertainty. Same thing, displacement time have error, velocity will have error, mass velocity have error, kinetic energy will have error, h and g have some error, t will also have some error. So the question is, how do you find that? So the step is as follows: always express it as powers. Express it as powers, meaning for this case, it is P is equal to F raised to 1, V raised to 1. In this case, V is equal to S raised to 1, T raised to minus 1, just like in dimensions. You bring it on the top. Here, kinetic energy is half M raised to 1, V raised to 2. Express it in powers. Here, root 2 is outside. It is H raised to half, G raised to minus half. G raised to minus half. Are you able to see that? Okay, express it in powers. Now, what is the next step? The next step is as follows. The relative error in this physical quantity will be, you write down the relative errors separately for each one of them. Delta V by V, delta F by F. Same thing over here. The relative error in the final quantity will be relative error in each quantity. You put them separately over here. Same thing here also. Relative error in kinetic energy, relative error in mass, relative error in velocity. Same thing over here. Relative error in time will be equal to relative error in H, relative error in G. Now, what do you do? Add, subtract. What do you just do over here? The answer is as follows. Always add, don't subtract, but you multiply with the powers before adding. So, force is raised to 1. So, 1 into this. Velocity is raised to 1. So, 1 into this and just add them. That's it. As simple as that. Always take the modulus of the power. Displacement is raised to 1. Time is raised to minus 1. Don't take minus 1. Take modulus only and then add. Here also. Mass is raised to 1. Velocity is raised to 2. Add them. That's all. Here, let's do it. Height is raised to half. G is raised to half only. Always take the modulus positive value and just add. That's all you need to do. As simple as that. As simple as that. Is it clear? So whenever multiplication, division, powers are there, what you do? First express it in the power form, just like you did it for dimensions. Everything on the top. Forget the constants. Forget the constants. Write down relative errors. Add them, but before adding, multiply it with the positive values of the power, modulus values of the power. Exactly. So imagine if somebody tells you, area of a circle has the formula pi r square and radius has a percentage error of let's say 0.6%, then error percentage error in area is how much? Very, very simple question. Let's see how to do this. Area is pi r square. Just like over here, it is expressed in power form. Forget the constant. So the relative error in A will be only one term is there. So delta R by R, nothing to add or subtract. The power of R is 2. So you multiply by 2. That's it. Best part, I can also write it in terms of percentage, because if I multiply by 100, it will become percent. If I multiply by 100, both sides, it will just become percentage. Now, wait a minute. The percentage error in the radius is 0.6. Oh, so 2 into 0.6 is 1.2%. So that's it. That's the percentage error in area. Percentage error in area is 1.2%. That's how simple this is. Clear, everyone? Okay. Let's see if you can solve the next level 1 question. Error in the measurement of the radius of the sphere is 2%. What is the error in the measurement of the volume? What is the error in the measurement of the volume? Yep, come on. What is the formula for volume? It is 4 by 3 pi r cube. So delta V by V, this is a constant. Forget it, is delta R by R, but 3 times. If this is percent, this is also percent. So 3 into percentage error in the radius is 2. So hence the answer is 6%. Hence, the answer is 6%, percentage error in volume. Now, please bear this in mind whenever we use these formulas in general. So, if P is equal to some constant P1 raised to alpha into P2 raised to beta, P3 raised to gamma, so on and so forth. And then you write delta P by P is equal to, forget the constant, alpha delta P1 by P1 plus beta delta P2 by P2 plus gamma's modulus delta P3 by P3, so on and so forth. This is valid only if the percentage errors are small. Percentage errors are small, like 5%, 6%, 2%, 10, like 8%, 0.5%, 0.6%. If it is small, only then this formula is valid. Otherwise, you have to go with derivatives. Otherwise, you have to go with derivatives. Yes, like for example, you will learn this later on also. Like there was a question which was asked in JEE Advanced. This is like proper level 3 kind of question, where when you learn mirror formula or lens formula, which is 1 by V plus 1 by U is equal to 1 by F, object distance and image distance have an error. What is the error in the focal length? So over there, you have to use proper derivatives like this. V raised to minus 1 plus U raised to minus 1 is F raised to minus 1. And now you differentiate this with respect to something. You differentiate both sides with respect to something. So V raised to minus 1's derivative using chain rule will be minus 1 V raised to minus 2 into dV by dx plus minus 1 into U raised to minus 2 into du by dx is equal to minus 1 into F raised to minus 2 into dF by dx. Minus 1, minus 1, minus 1 cancels. So dx also cancels. So V raised to minus 2 dV plus U raised to minus 2 du is F raised to minus 2 dF. So from this you will get dV by V square plus du by U square is equal to dF by F square. So, you can think as if this is some error, this is some error, focal length will have some error. So if you substitute all the values, you will get this. So you might have to do some kind of a derivative approach or some different approach if the problem is not of some standard value or beyond whatever I have thought. You might have to think literally out of the box. Literally out of the box. This is a proper level 3 question. Now let's look at one more question over here. Some quantity is raised to half, 2, 3, minus 4, A, B, C, D. Their errors are also given. This is level 2 question. JEE means it was asked, what is the final error in P? What is the final error in P? Come on, my dear lions, you can easily do it. P is A raised to half, B raised to 2, C raised to 3, D raised to minus 4. So think about it. Delta P by P will be delta A by A, delta B by B, delta C by C, delta D by D. What are the powers? Half, then 2, then 3, and then 4. And then just add them. That's all you need to do. That's it. And everything is in percentage. So half into delta A by A. A has an error of 0.2% plus 2 into delta B by B. It is having an error of 0.1%. 3 into delta C by C, 0.3%. 4 times delta D by D, which is 0.5%. Come on, do the math. It is 0.1% plus 0.2% plus 3 threes are 9, so 0.9% plus 2%. See how much is it coming out to be, my dear lions. 0.9 plus 0.1 is 1, 1 plus 2 is 3, 3 plus 0.2 is 3.2. So it is 3.2%. Let's see. Yes, option C. C for Captain Shreyas. Perfect. It is matching. It is matching. Everyone clear? All right. How about doing level 3 question? I think this should be one of the last questions for today's class. Yeah, this is the last question and level 3 question. Shall we do this? Shall we do this? Are you all excited? Because if you do this, that's it. This chapter is done, dusted, sorted for all of you. All because you attended today's class. In JEE Mains January attempt, your 4 marks to 8 marks are secure in your pocket. Nobody can take it from you. In JEE Advanced, one question might come on this as a combination with other things. Who knows? All right, let's solve this. Side of a cube is this, mass of the cube is this, the density is how much? Well, density is mass by volume. Volume is side length cube. Oh, so therefore, density is mass raised to 1, A raised to minus 3. Okay, that means if I go error wise, delta rho by rho, so if I go error wise, I'll put it over here. Delta rho by rho is delta m by m, delta a by a. A's power is 3, m's power is 1. So I just have to add them. Okay, perfect. So let's see what can we do over here. Delta m by m. Mass has some error. How much error? 1 gram. Out of how much? 2000. Okay, put it over here. Plus 3 into delta A by A. Delta A, change in the length 0.02 upon how much? 10. Perfect. Then the density is how much? Okay, the problem is, how do I solve this? Because I don't know rho. This will just give me percentage error. I think the question is not that. Okay, fine. You can also find percentage error. That's a different story. But I want to find delta rho also. That is my aim. So I have an idea. Come back over here. From this, density is, most likely density is mass by side cube. Mass was 2000. Side length was 10. So 10 cube. 10 cube is 1000. 2000 by 1000. 2000 by 1000. That's just going to be 2. 2 grams per cc or 2 grams per centimeter cube. Oh, perfect. I got rho. Rho is basically 2. Rho is basically 2. Perfect. I can just, if you want, multiply it and then find the value of delta rho also over here. So delta rho will be, if you multiply by 2, this will be 1 by 1000 plus 3 2s are 6, 6 2s are 12, but shift 2 decimals, so it will be 0.12 and one more decimal. So it will be 0.012, 0.012, or if you just don't like it, no issues. 3 into 2 into 2 into 10 to the power minus 2 whole divided by 10. So this will be 0.001 plus, okay, what will you just do? 3 2s are 6, 6 2s are 12, and 12 into 10 to the power minus 3. So that will make it 0.012. So this will become correct. I hope this is fine. Yep. 0.013. That is gram per centimeter cube. That is gram per centimeter cube. So hence, our final answer of density will be, 2 plus minus 0.013 gram per centimeter cube. That is our final answer. This is how I'll write it. So most likely the density will be 2, but there is an error margin which I have kept, uncertainty which I have got it from here. Is that absolutely clear, my dear lions? Yep. Everyone? Okay. Perfect. Great. Great. Yeah. This is how you solve the questions. And yep, 0.013. So one small thing, request, please like the session if you have not done it yet. Subscribe to the channel. Number two, uh, there is a link which is there in the description box. So let me just show that to you. It's for your benefit only. So going down. Do you see click here for Jungle Book? What are you going to get? Animals out here? Maybe. We'll find out. So you go over here. Promotion provide accurate details. Why am I getting this? Okay, let's put something. I'm from Bengaluru. Let me see if I get Bengaluru. Yes, Bengaluru. Continue. And here I will get the Jungle Book link. Just click on this. I have logged in before, that's why. If you don't log in, you have to create your free account. And here you will get the YouTube link, the date on which it was conducted. The PDF notes will be uploaded later on, DPP as well. Okay. So whatever I write on the screen will be available here. So every time you don't have to search for the PDF notes DPPs. I took in that extra effort for all of you so that everything is at one place. After some time, I will add more tabs when I get some time to consolidate all the different types of classes. Our old advanced class, VIT class, SRM class, BITS class, IIT class, UGEE class. So everything is at one place in this sheet. This is why we call it as the Jungle Book. Literally all the kinds of animals, insects, birds, everything are there over here. Got it? That is what it is. Okay. So I'll upload it, Divakar, very soon. The DPP, everything. All right. All right. Without blinking the eye. Wow. Very good. Awesome. So this is how our lectures are going to be. In fact, if you have anything to say, please let me know in the comments. All right. I'm going to start from the scratch, do level 1, level 2, level 3 problems also with PYQs also are there. My own questions are also there, concept is also taught, and everything is in one shot marathon in detail without skipping anything. That's the best part about the roar series. If you are serious about JEE 2025 2026, this is the only YouTube series that you will need. After this, self study, use your books, coaching material. If your coaching is not good, watch it over here, right? That is the reason why I'm conducting the classes. Many YouTube channels are there in Hindi. For English, you have us, and I will make sure that I give you quality content. Okay, so stay tuned on the channel by subscribing, liking, and commenting. I want your love and comments and likes. Obviously, I want it. I will be open about it, and you have to give it. As simple as that. It's a very simple give and take. Okay, thank you so much for all the quality content. Do not forget to subscribe. Do not forget to like and support the channel. Bye bye. Captain Shreyas signing off. Hasta la vista.